vendors or competitors of you or your employer. If you choose to take advantage of the interactive features available in the training, and we hope that you will, you are responsible for any information you choose to share. All right, at this time, I'd like to turn the program back over to your instructor. Hi, Sander.
Hey, John. Goedemiddag, everybody, and welcome back to our HCSA crash course, day 2. So I hope you stayed until the end yesterday, because then you know what is going on. Yesterday I messed up my disk and we are in trouble, and we are going to fix that today. Hey, did you see the ray of light that's shining on me? That looks so awesome. Good. Before I'm going to do the troubleshooting, I am going to walk you through a couple of slides. Just as a way to summarize what we've done yesterday to pick up, and then we are going to check out what is happening on my system and why it is happening and how we can fix it. So if yesterday you felt a little bit overwhelmed by all this information about storage and related stuff, that's going to be okay. And today it will become much better and you'll understand what is going on. So please make sure that you see the slide so that we can talk about Linux storage options. Now, what is going on? Well, there are different ways that you can deal with your disk. The primary way that has been around forever is the partition. Partition is a subdivision that you create on your disk, and you use it to allocate dedicated storage to specific types of data. In Linux, it is very common to have multiple partitions. Most of the times, your system will have a boot partition, a swap partition. It will have a root partition. All of these are used to separate different types of data on your disk. And even if nowadays we have stuff like LVM and Stratis and VDO, the partition still is the foundation. Now, how about LVM logical volumes? LVM stands for Logical Volume Manager. And Logical Volume Manager is introducing some flexibility in your storage. So LVM on RHEL is used as a default installation. So you will always see it on your systems. And LVM adds flexibility to storage. Now in RHCSA, there's not so much flexibility that you are going to investigate. But if you go beyond RHCSA, then you will learn about LVM snapshot, multi-device volumes, about data deduplexing, about RAID functionality, and so much more that can be introduced in an LVM. Excuse me. LVM is so rich that really I could teach a 2 or 3 day class just about LVM. The only thing that you need to know about for your RHCSA is how to resize it. And that's also one of the most important reasons why they started with Logical Volume Manager in the beginning. For those situations where you would have lots of space still available on one partition and you don't have any more space on another partition, what are you going to do about it? Well, the Red Hat solution is to use LVM. And then there is Stratis. Hey folks, when I created these slides, Stratis was still a part of the RHCSA objectives. Nowadays, it is no longer. Yesterday, there were some questions about it, but to give you a quick summary, in RHEL 8, 2 new storage technologies were introduced. These were Stratis and VDO. And you would see both of them in the RHEL 8 RHCSA objectives. Now we are RHEL 9, and in RHEL 9 we have neither of them. So you need to know about partitions, about LVM. You don't be able Stratis anymore. I think in this slide deck we still have Stratis slides. I'm just going to SAM-oriented crash course. I want to make sure that everything we do is related to the exam. A few words, what is Stratis about? Stratis is about thin provisioning. And it is API accessible. And because it is API accessible, it works well in cloud and containerized environments. Hey, AA is mentioning audio issues. I would like to know, anybody else, any audio issues? Joan, if you have an opinion about the audio, please do let me know.
Hi, Sander. It broke for just about 2 seconds, but it's clear right now. So I would just keep going.
Okay, I will keep going. Joan, please keep an eye on it, and if necessary, I will do my thing.
Okay, thank you.
All right. Yesterday we also talked about Linux block devices. So what is going on? Well, the Linux block device is the disk that you are going to use. When I say block device, then we are talking about a device that is doing block-oriented storage. And in most computers, that just means a disk. But if you access a disk or if you access a partition, that happens more or less in the same way. Yesterday, we have seen how you can use LSBLK to get an overview of currently existing block devices, where dev SD something is common for SCSI and SATA disks. So you have SDA, SDB, SDC, where the disks are named in order. VD, VDA, and VDB, etc., is what you would see in KVM virtual machines. And there's not much that I can say about the RHCSA exam, but I can tell you that the RHCSA exam is done on KVM virtual machines. So it is very likely that you are going to see VD devices on your exam. Now, it is likely, it's not guaranteed, because it all depends on how your KVM is installed. I mean, I can install KVM with the VirtIO driver, where the VirtIO driver is the virtualization driver provided by KVM, which makes that we get VDA and VDB, etc. I can also use the classic SCSI driver, and then it's just SDA and SDB, etc. Good. We also have NVMe, NVMe X and Y, like NVMe 0 and 1, and that is what you use for NVMe devices. Now, there's no need to memorize all of this. The only thing that you should memorize is a really useful command, which is LSBLK. PM has an interesting question. PM is asking, besides the exam, is Stratis and VDO used in the wild? Well, as far as I know, Stratis is still in tech preview. VDO is now integrated in LVM. And I'm hearing people about VDO, so probably it is used in the wild, but not very much. Most sites that I'm aware of are still using partitions and these logical volumes. Good. About partition numbering. We talked about partition numbering a little bit yesterday. So on SD and VD devices, partitions are numbered in order, where SDA2 is the second partition on the first hard disk and SDB1 is the third partition on the second hard disk. It's not rocket science, but it is something that you need to think about a little bit. Now, on NVMe devices, the partition names are appended to the device names, and you get partitions like P1 and P2 and P3 and P4, etc. So P1 is the first partition on the hard disk, and the changing thing is the P that is added. Now, you can also have NVMe devices like N3, which is really node 3, NVMe node 3. That means disk number 3, and P2, that would be the second partition. And again, I would say use LSBLK. LSBLK is cool because it avoids any confusion. LSBLK is getting its information directly from the kernel, where the kernel has this information in a file with the name proc partitions. And hey, I wanted to show you at this point, but I just realized that the only thing that I can show for now is a machine that is still in trouble. So I would like to tell you a little bit more about partitions. We stay on the slides for just a little bit so that we can investigate what is going on. GPT and MBR, we also need to know about that. MBR is Master Boot Record, and Master Boot Record is a part of the 1981 PC specification. Very old. In MBR, you have 512 bytes to store boot information and 64 bytes to store partition. And in these 64 bytes, you can only store 4 partitions. And also, the maximum size in MBR, the maximum addressable disk size, that is 2 TB. The little I is indicating that we are talking about 1024 times 1024, and that a couple of times, and that is why you should say tebibyte. That is a standard nowadays. So you will notice that in the future I will talk about gigabyte and terabyte, but hey, really what's going on behind the scene is tebibyte and gigabyte and megabyte, etc. Now, that's not the important thing. The important thing is that if you want to go beyond 4 partitions, you need to create one extended partition. You can have one extended partition, and the extended partition has one purpose only, and that is to create logical partitions. So logical partitions are created within the extended partition. That's also important, and that's what we have seen yesterday. Now, also, fun fact, if you are using logical partitions on MBR, the first logical partition is always partition number 5. So you could create a disk, and on your disk you could create one extended partition and start using logical partitions immediately. Then you would have an SEA1, and the next partition would be SEA5 and SEA6 and so on. Apart from MBR, there's GUID. GUID is Global Universal ID, and the GUID partition table, or GPT, is a new partitioning scheme that has been introduced in 2010. Most compelling reason why GPT was introduced was because of disk sizes. In 2010, disks with a size bigger than 2 terabyte became pretty common, and you wanted to address them, so we needed something new. And you will notice that in GPT there's more space to store partitions, and as a result you can create 128 GPT partitions directly. There is no more primary and extended partitions, it's just a partition. So that makes GPT a bit easier. Now you will notice that in cloud environments, in many cases, MBR is still used. And for the RHCSA exam, it's also very likely that you are going to work with MBR and not GPT. By any means, MBR is more complex, and that is the reason that I'm teaching MBR and not GPT in this class. Because if you know how to deal with MBR, you will definitely get around with GPT. If you know how to deal with GPT, you might have some trouble understanding what MBR is doing. Then we talked about partitioning tools. FDisk has been around since the earliest Linux versions, and as I told you yesterday, FDisk is the standard utility that I'm explaining. For the simple reason that FDisk offers easy access to advanced features, and it's still an up-to-date utility. Now, there was a moment in time with the release of RHEL 7 that it looked as if FDisk was going to be abandoned, and Apartheid would be the new utility. But the FDisk guys continued developing FDisk, and it's a very rich and very powerful and also very accessible utility. And that's why I like talking about FDisk and explaining FDisk. In Parted, and I have that somewhere on the slide as well, in Parted things are just not as handy as they are in FDisk. You may hear about GDisk. GDisk was introduced to offer GPT support. Nowadays on RHEL 9, FDisk also has GPT support, so there's no need to run GDisk anymore. And Parted was introduced to make partitioning easier, and the benefit is that it can be scripted easily. The disadvantage is that advanced features are a little bit hidden. AS is asking, is there any limitation about the number of logical partitions? The maximum number of partitions that you can have on an MBR disk is set to 15 in total. So you can't have 128, the limit is at 15 because of the way now Linux is addressing the block devices. Video stop. I don't know what's going on. What I care about is that you can still hear me, FS. but I'm keeping an eye on your feedback. And Joan is keeping an eye on it as well. And that is pretty important. Good. Partition type. And thanks for letting me know, folks, that it works. So what did I do? Just a little bit of background information. I told you about redundancy. I'm on a dedicated personal gigabit internet connection today. It's no longer a shared internet connection, which is what I was using yesterday. Normally, I always use a shared internet connection, but we had trouble yesterday. I do not like having trouble at all. So I brought up the redundant internet connection, and that is what I'm working with today. That's why I'm not expecting too many issues here. Well, if there is any issues, then at least I know it shouldn't be because of the connection. But keep on posting if you have any issues, and refreshing your browser setting, that would work. Good. We need to talk about partition types. What is a partition type? Well, partition type is a low-level identifier of the operating system. And the fun thing is that partition types are mainly important for your RHCSA exam. You will notice that currently partitions will work even if the wrong partition type is set. But on your RHCSA, you need to set partition types. And we have a Linux partition, we have a swap partition, we have a UEFI partition, we have an LVM partition, and these are important. Now, I don't have insight in the way how Red Hat is grading the exam, but I do fear that if you are missing to set the partition type later when you create swap or LVM, it's going to cost you points. I will demonstrate, no worries about that. Then about file systems. Yes, my friends, I have a couple of slides. I have 6 more slides, and then we are going to do hands-on. Finally, we are going to do troubleshooting. So about file systems. The file system is the way how your files are organized on disk. And the default file system on RHEL is XFS. That's the default file system since the release of Red Hat Enterprise Linux 7. Apart from XFS, which is fast and scalable and which uses copy on write to guarantee data integrity, there is also ext4. ext4 was the default in RHEL 6, is still used, and you will notice that many other Linux distributions are still using ext4 as the default. Now, in file systems in Linux land, there was a little bit of a challenge. And the challenge is that new developments are happening in the storage world. And one of the new developments that happened outside of Linux is the ZFS or ZFS file system. That's a very powerful file system with pretty nice features, which has a license that makes it can never be used on Linux. And for that reason, and this was relevant in the days that the RHEL 7 was released, year 2014, for this reason, Red Hat has been wondering, what are we going to do with the file system? They considered the Linux alternative for ZFS, which was ButterFS, BTRFS, not mature, and that is why Red Hat has never included ButterFS as a stable file system solution. And I'm wondering if they are ever going to do that. And that is why XFS is a default in RHEL 9 still. And if you want to, you can also use ext4. You make the decision about the file system when you create a partition. I would say go for the standard, but do realize that XFS file systems, their size can be increased, not decreased. Now, decreasing a file system is not something that all people are commonly doing. Some environments, well, I can say many environments are never ever going to decrease a file system. But if this is important for you, the ability to decrease, you probably should use ext4. ext4, and that's funny, goes all the way back to ext2. And ext2 was introduced with the introduction of Linux in 1992. That makes ext4 based a little bit on very old technology, and that's also why Red Hat has chosen something more recent, XFS. In ext4, they're using a journal. The journal is a transaction log, and this transaction log guarantees data integrity, and that's going to be important if ever your system crashes while you were committing writes. Where ext is using a journal, XFS is using COW, copy on write, which is a more efficient solution for the same problem. Also on Red Hat, you have a vFat. What is vFat? A vFat is a Windows file system, which is completely available in open source. And that is the reason why it exists in RHEL 9. Because sometimes you want to write a partition that is readable from other operating systems as well. And then vFat is the solution. You can also use it for shared devices. If ever you want to format a USB thumb drive, give it vFat. ButterFS, I told you about ButterFS. It's new and it is advanced and it is not installed, neither supported by Red Hat at the moment. Now, how do you create them? By using MKFS. We have seen MKFS yesterday. MKFS has different utilities, like the .xfs, the MKFS ext4, the MKFS vFat. Hey folks, don't go remember all of these utilities, just use MKFS tab. That will show you all the available file systems on your system. One thing that you should be aware, if you just type MKFS without file system, then it will create an ext2 file system. ext2 really is very old. You don't want that to happen. So be specific and tell MKFS what exactly you want to use. And next you can mount it. Now, mounting is something that you do in runtime. When I say in runtime, I mean here and now and not persistent. Like mount dev vdb1 on /mnt. And if ever you want to disconnect a removable device, don't forget to umount it. LSOF can be helpful, and the mount command can be helpful to give you an overview of mounted file systems. Find MNT or LSBLK is another way of showing you the file systems and the block devices and where they are currently mounted. Almost there, folks. 3 more slides, and then we are going hands-on. Wow. This is almost death by slides, isn't it? So many slides. I do apologize. We'll be more hands-on as I move forward. But etc FS step. This is the main configuration file to persistently mount partitions. So you want your partition to automatically be mounted on system start. Put it in etc FS step. This is definitely an important skill for you on the RHCSA exam. I can guarantee that you are going to edit etc FS step. So what do we see in etc FS step? First, the name of the device. Then the name of the directory where you want to mount it. You must create the directory on beforehand. Next, the file system. Then we have defaults, which is the mount options. And then we have 2 legacy options. I don't want to explain them because the 3 minutes it takes is a waste of time. Just always make sure that they're always set to 0 and 0. And for more details, man 5 FS step will show you what column 5 and column 6 are all about. Now, etc FS step content is used to generate systemd mounts. And later, when we talk about systemd, you will see that the FS step mounts exist as systemd mounts as well. And, well, I am going to not say this because what I have here on the slide, I'm just wondering, why did I put it on the slide? To update systemd mounts. Now, you don't have to do anything because systemd is very smart and systemd will pick up changes in etc FS step. AS is asking, is it possible to update the file system type dynamically, like ext2 to ext4? Well, for ext old to ext newer, there's an in-path update. Apart from that, if you want to go from ext to XFS or something like that, there's no in-place update mechanism. And I would say just create a new file system. Because even in ext2, depending on how it was created, you might miss features, and I don't believe in place upgrade utilities. Create a new file system, copy all the files over. That's probably a smarter approach. All right. How do we avoid problems while booting? Yes, AA, that's correct. So how do we avoid problems while booting? Well, if an error was found in etc fstep, your system will drop a troubleshooting shell. Hey, let me show you my system, because this is exactly what happened yesterday. Here is my system, and here you can see what happened yesterday. I had problems, and because of these problems, I now have a troubleshooting shell. Now, before we are going to do the troubleshooting, we need to talk about avoiding to get into the troubleshooting shell. What should you do? Well, smart move is if you type mount -A. You make changes to etc fstep, first type mount -A. Mount -A means that etc fstep is trying to mount everything that has not yet been mounted. And if there were any errors, then it is very likely that these errors will show immediately, and you can fix your problems before getting in boot troubles. You can also use find mnt --verify to verify syntax if you want to do that. But we need to fix what is going on, and I can already tell you what is going on. We are going to investigate that in a little bit, and we are going to see that the partition number 5 has changed its name. What yesterday still was partition number 5 is now partition number 6. No, it's the other way around. What yesterday still was partition number 6 is now partition number 5, and that's the topic that I'm going to tell you about. Disk device names, the hard-coded disk device names, are subject to change, so they can suddenly be different. And how are you going to handle a situation where that is happening? Well, you can use labels and UUIDs. I promise, this is the last slide before we are getting our hands dirty. So in data center environments, block device names may change. That is because block device names are created according to your storage topology. And if your storage topology changes, your block device names may change. And that's exactly what happened yesterday. So what previously was partition number 6 has now become partition number 5. And I can see that it has tried to load partition number 6. We still see it on the second line from the top on my shared screen, but partition number 6 does no longer exist. Now, the Linux boot procedure considers this a critical issue. If suddenly you can't access your storage anymore, that is considered a critical issue. And what are you going to do about it? Linux drops a troubleshooting shell. Now, on your exam, this is definitely a critical issue, because if at the end of your exam you leave your exam environment in a troubleshooting shell, you will get 0 points for that entire virtual machine. And you know what that means? Even if you have 2 virtual machines in total, that will mean that you have failed your exam. And that shouldn't be happening. And that is why you want to avoid problems like this. And one way to avoid is by using these options for persistent naming. There is 2. Option number 1 is the UUID, the Universal Unique ID. That's an ID that is automatically generated for each device that contains a file system. Alternatively, there is the label. You can manually set a label using the file system creation utility. So mkfs.whatever minus uppercase L, and you can give your file system a label. In past, labels are pretty common. Nowadays, UUIDs are more common. Even if UUIDs are pretty unreadable. And that's what I'm going to show you. Yeah, let's do it. Hey, FS, if you want to be interactive in this class and participate, do not use Q&A, use group chat, please. Folks, you may have missed it yesterday, but I always see group chat in front of me. I don't see Q&A in front of me. If you post in Q&A, it can take significant time before I react to it. Q&A is for questions that are not urgent and that you don't want me to miss. Group chat is for anything that relates to what I'm talking about at this moment. Okay, back to my system. I'm going to troubleshoot. So it needs my root password. We are in what is called the emergency target now. That's what we see on the system. You are in emergency mode. And in this emergency mode, I need to enter my root password. So here is my root password. And I can type lsblk, and lsblk is showing me all the mounted devices. So I can see /boot is mounted. I can see partition 3 is mounted on /my files. I can see a rel root, that's an LVM logical volume, is mounted on the root directory. And I can see NVMe 0 and 1P5, which isn't mounted anywhere. Before troubleshooting, I would say verify writability. I'm using touch anything to verify that I can write. I can write, so that's okay. So I can continue. And what am I going to do now? Well, I am going to check my etc fs step. So in etc fs step, what do we see? We see an etc fs step that I'm trying to load partition number 6. We don't have partition number 6 anymore. How come? Well, generically, because sometimes storage device names may change, and that's exactly what has happened here. The name of my partition 6 has changed. It is now partition 5, as we can see in the output of lsblk. If you look at fs step a little bit more, you go up 5 lines, then do you see the line that starts UUID equals? That line is using a universal unique ID. So we need to mount by using a universal unique ID. I am going to tell you about this awesome utility block ID, BLK ID. BLK ID is giving me universal unique IDs of all of the block devices. So what am I going to do? Well, I need the UUID out of the P5 line, right? So BLK ID, and how do we get it out of there? I think we should awk it. And using awk, I'm going to look for N1P5. And next, I'm going to print $2. Awk has an awkward syntax. So, yeah, I was afraid of it. N1P5, yeah, I'm missing the ending slash. Now it is better. This was just me not paying attention. It's complaining about an unterminated regular expression. I'm not sure if you have used awk in this way. Text processing utility, it's very powerful. Awk works with an awk command. The entire command is between the quotes, the single quotes. The first part is a regular expression, N1P5. So I'm looking for lines that contain the text N1P5. That's my partition number 5. And I'm doing a print $2 on these lines. I want to see the second column. And this second column is the UUID that I need to have in my etc fs step. Now, if you are very aware of what you are doing, feel free to use a double redirect. So double redirect /etc/fs step. Make sure you don't use a single redirect, because then you would crush the entire content of your currently existing etc fs step. That would be dramatic, but that's not needed here. I'm appending the UUID that I need to the end of etc FS step, and that is going to work. And at the same time, this allows me to tell you about this awesome awk command. And really, even if the syntax is awkward, this command is so powerful. So I would really suggest practice it because you are going to like it a lot, and it's going to make so much things so much easier. Now I'm getting to etc FS step. Hey, for RHCSA, by the way, there's only one editor, okay? And this one editor is Vim. You want to use Nano? Well, I'd say don't, for the simple reason that Nano is not always there and VI or Vim is always there. Good. I want to mount my previously known as P6 on part 6, and that would be ext4 and defaults and 0, 0. Now, when I do this, I get a common question. Hey, do we need to double quotes? Well, double quotes are never really interpreted by the bash shell. And the only function of double quotes is to make sure that you don't get in trouble because of spaces in your strings. So with or without double quotes, the UUID is going to work. You probably see the difference between the UUID that I'm mounting on /boot and this one, which I'm mounting on /part. With or without double quotes, it's working all right. Good. I'm going to save these changes, and then I'm going to reboot. And after the reboot, we should be good. And do remember, everybody, this is critical stuff, because if during your exam your virtual machine doesn't boot properly, you will fail the exam. So this is really important. GC is mentioning another approach. Well, you know, whatever you are using, whatever works for you, use it. As I told you yesterday, if you don't like my approach, you have a different approach, you are very confident with that, then you are good. And TL is asking, once we start mounting with UUID, can we mount again with device name? Yeah, you can make a mix if you want to. TL, that is what I was originally doing in my environment. So we had the boot device. Boot device by default on a Red Hat installation is mounted using the UUID, and I have used my NVMe device name besides that, and that works perfectly. Using LSBLK, and LSBLK is showing the currently mounted partitions, and there we go. This is all right. And now I see this GC you are mentioning. I rather send the LSBLK greater than val and vim -o etc fs step dot val. If you send the output of LSBLK to a file, well, that is not going to work because LSBLK doesn't show any UUIDs here. All right, this is what we needed to know about troubleshooting. Wow, that was a lot of stuff. Now, what I want to do next, I want to briefly tell you about labels. So here we have what? Yeah, that's possible. Okay, GC is talking LSBLK -fs. Sometimes I'm very dumb, GC. If I see something in the group chat, then I'm not thinking any further on occasions. Fine, the -fs. I repeat my previous statement. If you have a method that works for you, please use it. I hope you also understand, for educational purposes, I don't want to present different methods to do the same thing because that would only be confusing. Right, what do we see? We see partition number 6 is mounted right now, or partition number 5 is mounted on the directory /part6, and that is what we wanted. Now, if you talk about labels, labels are manually assigned, and you need the appropriate utility. First, mkfs whatever. Let me do an mkfs xfs -help. And oh no, this is MKFS. Yeah, MKFS.xfs doesn't know about minus minus help. This is a weird utility, but it's giving me the help that I wanted anyway. Minus uppercase L label, maximum 12 characters. So if I want to, I can use no, not MKFS. Yeah, if I want to, I can use mkfs.xfs on dev sdb1. Notice this device doesn't exist. I just want the command to be in the history. Minus L, my label, and that would set a label on the device. There you go. Minus L, my label, uppercase L, my label, to work with a label. You can also do this on existing devices, and that's what I want to show you. If the existing device is XFS, there's a bunch of XFS-related utilities. We need XFS_admin minus minus help, which is showing minus L label. So minus L label on device, so that would make XFS_admin minus L my XFS on /dev/nvme0 and 1p5. And oh boy, it's complaining. This contains a mounted file system. XFS_admin doesn't work very well on mounted file systems, so I need to umount /dev/nvme0 and 1p5. Then I can try it again, and I have just use the appropriate command. And hey, I was testing if you're paying attention. And if you would have paid attention, then you would have said, hey, Sander, your partition number 5 is not XFS, that is ext4. And that is totally right. I'm trying to do this on ext4, and that doesn't work. That's why I'm getting not a valid XFS file system. Use -F to force a read attempt. I'm not going to use -F. I'm using tune 2fs -L my ext4 on dev nvme0 and 1p5, and that works all right. I've set my label. Now if you want to mount your file system by label, that's also possible. Edit etc fsstep, and in etc fsstep, instead of uuid equals, you are going to use label equals. Label equals my ext4 on /part6 as an ext4 and defaults and 0 and 0. I hope you understand that by using the hash in front of this line, I'm not really going to use it, but I want you to be aware of it. Now, I feel I need to react on what TL is saying. TL is saying instead of uuid, to correct the problem, we could change the partition name only. TL, the problem here is that depending on your system configuration, these hard-coded device names sometimes change. So that really is not a guarantee. As a hard-coded device names can change beyond your control at the next reboot, you might be in trouble again. My sincere advice, mount everything you mount. If it's a classical partition, if it's an ordinary partition, mount it using UUIDs. Don't do labels. Labels was nice in the 1980s. Nowadays, you don't do labels anymore. You want to be cool, you use UUIDs. And just live with the fact that UUIDs are hard to read and hard to compare. It's the way it works. Use UUIDs, they're a system default. So if next you want to say, hey, Sandy, you still have partition number 3 hard-coded. Yes, that's right. I should also rename my partition number 3. I'm not going to waste our time together to do so. And if next you are asking, how about LVM device names? LVM device names are different. They don't change suddenly. And that is why LVM device names still are legal. Hey, FS, you are mentioning that group chat is not working. FS, just reset your browser. And Joan, can you post the appropriate stuff to FS who is posting in Q&A. I can see you're on it. Thank you very much, John. You're fantastic. Okay. Also cool to name. Unique device names are created in dev disk. JP, your test is working. Yeah, well, JP, we have seen that it works, right? So I'd like to show you BLKID. BLKID is showing all of these UUIDs, okay? Now, behind these UUIDs, we also have the dev disk directory. What is Linux doing? Linux is giving you a subdirectory in /dev/disk to allow you to address storage devices in different ways. Where we have a by UUID and a by label. If I use ls-l on by UUID, let's just remember that my partition number 5 is a UUID that ends in E5E2. So by UUID, and what do we see? Hey, here we have the partition number 5E5E2, which is a symbolic link. I wanted to mention this because sometimes you will see /dev/disk/by UUID /BA1A7707 and so on. So instead of UUID equals, you might see the dev disk device name. And they are completely equivalent. It's just a different way to get the same device. This dev disk device name really is convenient. Also to access iSCSI devices, if you're in an environment where you are using iSCSI devices, for instance, it provides a fantastic uniform way to always access your device names in a way that works. This dev disk directory is really important enough to tell you about. Okay. I told you about persistent naming attributes. What is this? Okay, BLKID. I'm having a look at the slides. Can you please double click the slides icon third from the left in the course controls? Where you can see BLKID. We talked about it. You now know what it is. Tune 2FS-L. This is what you use to set a label on an ext file system. In case you are wondering, what is this 2 in tune 2fs? Well, tune 2fs is a contraction between tune and E2. And E2 refers to ext2. And yes, this historically is a tool that comes from the ext2 file system. So tune 2fs was originally created for ext2. As ext4 is built on top of ext2, it can still use the same utilities. There's no tune 4fs, for instance. You'll see that in many other utilities, they have E2 in the name. And if the file system utility has E2 in the name, it really was created for ext2. Right, XFS is XFS_admin. I would remind these utilities. These are important utilities anyway. You might have to do this on the exam. Another thing, and that's about swap. And you know what? I want to give you my minimal introduction to swap. And I'm going to show you my cool picture. I have my drawing application. And I need to bring up the drawing application. But I have this awesome picture, and I don't like sharing holiday pictures, but I'm convinced that you think this is as awesome as I think it is. But hey, we are not here to talk about my adventures on Greenland. Let's talk about swap. So what is swap about? You should be seeing my drawing application at the moment. Swap is emulated memory on disk. And I want to give you a short introduction to why using swap matters. If this is RAM, RAM is always a resource of which you never have enough. Let's say you have a server, and on your server you have 8 gigabytes of RAM. So what are you going to do with your RAM? Well, RAM is used for a couple of reasons. To load your kernel and all of its tables and I don't know what. RAM is used to load application memory, and RAM is used for caching, cache and buffers. And I will show you in top in just a little bit when we go hands-on again why this is relevant. Now, you never have enough RAM, and there's a few things that you need to know about RAM. The Linux operating system likes using cache. Why does it like using cache? Well, cache is about files that you have recently accessed, and if you store your recently accessed file in cache, then the next time you need to have access to your file, you don't have to fetch it from disk anymore, and that will make the process very efficient. That's also why on Linux systems you normally don't see much available memory. Even if you have 32 terabytes of storage on your Linux system, eventually all will be used because Linux is just going to cache it. Now for cache, it's very easy. If you have a shortage of memory, then Linux is just going to clear cache. And then you will have more memory available. But for application memory, it's a little bit more complicated. Application memory is your application code, and your application code just needs to be loaded, and you can't kick it out. So what are we going to do? If we have a shortage of memory, then Linux is going to consider active versus inactive memory. And it can do that for cache. It can also do that for application memory. And what are we going to do if we have inactive application memory? Well, if you have inactive application memory, then you are going to move it to a special area on disk, and that is your swap space. The benefit of moving your inactive application memory to swap is that you have more memory available for things that do really matter. That is why that is how it works. Now, swap on Linux is really very convenient, and most Linux systems do have swap as a default solution. And for R8CSA, you need to know what to do to allocate more swap space. So let me get back to the shared system so that I can tell you about it. Shared system coming up right now. There we go. The first thing I would like to show you is the free-m utility. Free-m is showing memory usage in megabytes. What do we see? We see that I have 3.6 gigabytes. Just because it's easier to talk about it, I will call this 4 gigabytes. So we have, let's call it 4 gigabytes of memory. Of the 4 gigabytes of memory, 1.5 is used, 1.5 is free. So nothing really to worry about. We can also see buffer and cache 753. And this magical parameter, available memory. Available memory considers free memory and also all the memory in buffers and cache that is not really actively used. As I told you, Linux has a notion of active and inactive memory. And the thing is that if more memory is needed, then Linux can clear your inactive memory to make more memory available. And that is how we get an available of 2064. We can also see swap, and there is nothing happening in swap at all. So that's a little bit boring. Now, by default, you have swap space. And if you use swap on minus S, then you can see all your swap devices. I'll tell you about devdm once we get to LVM, because this is an LVM logical volume. Swap on minus S lists it as a partition, and that is okay. I have 2 gigabytes of swap space. That is what matters. Now, regardless of the fact that I completely do not need swap space at all, I am going to show you how we are going to allocate additional swap space. If you want to allocate additional swap space, you need to make a choice. Either you create a swap file or you create a swap device. And the swap device is what is common. OA is asking, is there a rule of thumb how much swap is needed on a system? Well, the rule of thumb is a little bit complicated, OA. First, check the main application on your system. Some applications, like Oracle database, have a very specific requirement to the amount of swap. It's like double the amount of RAM must be available in swap. So you have half a terabyte of RAM, then you need a terabyte of swap space. Really? Yeah, really. If your main application says so, then you shouldn't do it in any different way. The generic rule of thumb on low memory systems, and low memory systems is everything lower than 1 gigabyte, was always double the amount of RAM in swap space. Now that we get high memory systems, like half a terabyte of memory, on high memory systems, you typically use 25% of RAM in swap space, but it really depends on what you are doing with your system. Some systems can't be configured with swap at all. So make sure that you know what is going on. Priority is not an interesting parameter. It's about load balancing if you have multiple swap devices, and leave it to the operating system. Really, it's not worth the time spent on the explication, MB. I hope you forgive me. Let's do fdisk on dev nvme 0 and 1. I want to create a swap partition. Swap partitions are probably the most interesting ones. Using P for print, I just want a reminder of my current partition table. Using N for new. And what do we see? All primary partitions are in use. Adding logical partition 6, that is okay. Now look at the first sector. It wants to create a new partition that starts at 44042240. That is before the current partition number 5. I don't want that. I want my partition to start after the current partition number 5. We are going to do something with the remaining unused disk space later, but not now. So I'm manually going to enter 403.357 44 as a start point of my new partition. So I'm taking the endpoint of the partition right before that, and the next partition is what we are going to need. Last sector, let's make that plus 2G for 2 gigabytes. So now it has created a new partition 6 of the type Linux. That's good. Now P will allow us to verify, and we need to do something about it. On the exam, do not forget what I'm going to show you now. What is that? Well, we need to set the partition type. Look at the last column. And in the last column, you can have some identifiers for what you are doing with your partition. And that's what we need here. I need to set my partition type. I'm using T for type. Then I'm telling it I want to set the partition type for partition number 6. And then it's asking hex code or alias. Type L to list all. This is very nice because in older Linux versions, or I should say in older versions, decimal code. 3 is Linux, 82 is swap, and 8E is Linux LVM. These are the most important ones. Nowadays, I can also type LVM. Sorry, that was wrong. I don't want to type LVM, so I need to go there again and repeat. Nowadays, I can also type swap to make it a swap partition. And there we can see that it changed the type of partition to Linux, from Linux LVM to Linux swap / Solaris. I don't know what Solaris is doing in there. I do know that now my partition type is set to 82, and that is what I need to create swap space. So I'm happy, and I'm going to use W. Using LSBLK and LSBLK, that contains an L, and there we can see this new 2 gigabyte partition. What are we going to do with it? Well, I am going to use MK something. The easy thing to remember, if you create a traditional partition, you need MKFS to create a file system. And a file system is the structure that you are going to use to store files on the partition. Now, in this case, I'm not going to create a file system. I am going to create swap. So mk swap is what we need. Mk swap on dev nvme 0n1p6. And that's setting up the swap space. At the same time, it has added a UUID as well. So what are we going to do with it? Well, I am going to put it in etc fstab. And hey, my story is the same here. I want to use UUID to mount it because my partition name might change. Well, I will tell you, it will probably change later on when I'm doing another demo. So my partition ID might change. So I need etc fstab. In etc fstab, I am going to put UUID equals, and this time I used my mouse just to make it easy. So UUID equals. Then we need a mount point. Now the mount point for swap surprisingly is none. I don't really like it. In older versions of RHEL, you would mount swap on the kernel interface swap, not slash swap, not slash none. Excuse me, just the word none or the word swap. In case you have a hard time remembering this, just have a look. etc fstab that is going to mount it. So UUID equals whatever. I'm mounting it on none. The file system type is swap. And thank you very much, JP and DM. I overlooked that. Thank you so much for mentioning it. I will remove it, but I first complete the line here. And there we go. Now it is better. So my fstab is updated. Using 3 minus m is giving me what? Well, it's giving me nothing. I added a line to etc fstab. Do you really think that if you add a line to etc fstab, anything will be updated automatically? Of course not. This is Linux. And if you want to update it, then the option would be swap on my. Now I use 3 minus m, and yay, I have 4 gigabytes of swap. Swap on minus a is showing it. Swap on minus s is showing all the swap devices. And hey, what do we see? We have minus 2 as priority for the first device and minus 3 as priority for the second device. So that is we needed to do. Don't post one word with a question mark behind it. It leaves me interpreting what does he want to ask. Be more specific. TL is asking, in the exam, if it's not mentioned to mount using UUID, is it secure to mount through the device name? TL, I repeat, device names do change unexpectedly. Let me return the question, TL. Do you want to risk that during your exam something changes in the topology and suddenly your device names are not the same anymore? The result will be that you will fail your exam. These exams are pretty expensive. I think this is enough as a question. And in case it's not, no. CM is asking, does creating the volume automatically format it? CM, looks as if you just joined and missed yesterday's session. First, I need to tell you, don't call it a volume, call it a partition. Volumes on Linux are specific. Creating a partition does not automatically format it. No. That is why we have the MKFS utilities. Make sure you watch the recording of yesterday's session, the last hour or so, where I'm spending quite some time on explaining MKFS for your file systems. Okay, it's almost time for a break. So I am going to have a look at this managing swap slide. So swap is RAM emulated on disk. And all Linux systems should have at least some swap, unless your main application tells you not to. I'm pretty sure some of you guys are using Kubernetes, and Kubernetes is one of these examples that doesn't work on systems that are using swap. Then you cannot have swap, you need to disable it. And the amount of swap really depends on the use of the server. And swap can be created on any block device and also on swap files. I might be talking about that later. Partition type is set to Linux swap. That is an important one. Hey, Joan, can you post information about how to find yesterday's recording in the group chat, please? Thank you very much. Right, after you create the swap partition, you use mkswap to create the swap file system. Really, you can consider swap a file system, and mkswap is how you are going to create it. And you can activate it using swap-on. Swap-on to specify a specific device, swap-on -A, which is going to activate all of them. And OV is saying, I followed the steps, but I still don't see swap in 3 -M. OV, then you didn't follow the steps in the right way. OV, I edited. Now let me summarize the relevant commands. Command 174 is where I used mkswap to create the swap space. After creating the swap partition, make sure you have used mkswap. Without mkswap, it doesn't work. Then I edited etc fstep, and then I used swap-on -A. I'm pretty sure, OV, that you have missed one of these steps. But I have good news for you. It's break time, so you have a couple of minutes to figure that out during the break. Let me also print the line from etc fstep that I have just added. For those of you who are interested, feel free to practice this stuff and practice it by doing this managing partitions lab. And I am not going to give you time to work on all of the labs, but I do want you to work on this lab. So this time you are getting an incredible 16 minutes in the break, because I do want you to have time to go get a cup of coffee or whatever you need. I also do want you to work on this lab, so that if there is anything you do not understand, we can talk about it before moving on. The reason I'm doing this is that managing storage really is very important in RHCSA. And if you don't understand how to create partitions, you are definitely not going to understand how to create logical volumes. And then you are going to leave me, and if you leave me, I'm all alone here. I will be sad. I don't want to be sad. I want you to be successful on your RHCSA. So do the lab. For those of you who have no clue where to find the lab, if you double-click the third icon from the left, you have access to the slides, and you can see the lab popping up. And with that, 16 minutes for the break. I'll be away for about 8 minutes, and after that, I'll be back. So if you have any questions during lab time, I will try to answer them as fast as I can directly by answering in the group chat. So post your question in group chat. I'll probably find it, send you an answer. If I don't find it, post it again, because if group chat is busy, I'd scroll away. Are you still listening to me? What are you still doing here? It's break time, dude. Go get some coffee and work on the lab. I'll talk to you in 828 seconds. Enjoy your break. Hello, everybody. Break time is over. How have you been doing on the labs? I'm going to ask you a question because I'm wondering. Oh boy, they changed the interface, so I need to look where it is. There it is. Uh, I want you to give me thumbs up if you're okay and you don't need me to walk through the lab. I need you to give me a thumbs down if you want me to walk through the lab. So you can see a thumbs up, thumbs down interface appearing in the course interface. And thumbs up means no explanation, move forward. Thumbs down means please show us a solution for this lab. Uh, please let me know. I'm giving you a little bit of time to see what is coming in. And good. I do have quite a few people who want a solution. I'm going to give you a quick solution. So, quick solution, here you go. You should also know that even if you are having a hard time with this lab, we will do LVM, logical volume management, and we'll do partitions again. So I will make sure that by the time we are done, you know what's going on. Okay. Just to confirm that we have NVMe 0 and 2, a second disk. That's the disk that I'm going to use. Using fdisk to create a primary partition with the size of 1 gigabyte. Hey folks, look at the wording in the exam. If in the exam they are asking you for primary partitions and logical partitions and stuff like that, then you know it's MBR they want you to do, right? So I'm going to create a primary partition with the size of 1 gigabyte. So fdisk on dev nvm NVMe 0 and 2. Using N for new and P for primary. And partition number, that should be 1, and we make it first sector, that should be 2048. That's the default first sector, and we make it plus 1G for 1 gigabyte. Right, I'm reading ahead because I can see we also need an extended partition that includes all remaining disk space. So I'm using N again, and I'm using E for extended. And partition, well, partition number 2, that's okay. First sector, last sector, that's just an enter and an enter because I want to use all of the remaining disk space. And by pressing enter twice, I make sure that I am using all of the remaining disk space. Now, in this partition, we need the 500 megabyte XFS partition and mount it persistently. So that's a logical partition, right? N for new. And look at that. fdisk is so smart to tell us, hey, all space for primary use. Adding logical partition 5. Do remember, logical partitions are numbered in order. The first logical partition is always partition number 5. That's okay. I'm making it plus 500 M for 500 megabyte. No worries. If on the exam they're asking for a gigabyte or gigabyte, just 1G and 500 M is okay. On the exam, they are most likely going to tell you that there's some tolerance, and if it's more or less the amount they're asking for, then you are good. Right. I also need a 500 megabyte swap partition. So N for swap, first sector plus 500 M. And that's a swap partition, but hey, swap needs the type to be set to swap. So T, partition number 6, and the type is going to be set to swap. Here we go. Quick P for an overview, and I can see that we are doing all right. So I'm using W, yeah, as you have seen, I tried to do everything I need to do in fdisk all at once. That makes it more efficient. So I need to create some mount points. mkdir minus p / mount / files / mount / xfs. And then I need to create some file systems. So mkfs.ext4 on the primary, dev nvme 0 and 2 p1. And what is going on? NVMe 0 and 2 P1 does not exist. Hey, what's going on? LSBOK, I don't know what's going on. NVMe MVE0 N2P1. Did I make a typo? I made a typo. And MVE, that doesn't work. That's why I hate NVMe device names. Now it's doing so much better. Then XFS on partition number 5. But we need a label as well. So mkfs.xfs on dev DME0 N2P5 minus uppercase L. Minus uppercase L, my XFS. Oh boy, did I already use my XFS? I'm not sure about it. Apparently not. So that is okay. And then we need to create a file system, the swap file system on the swap. So mk swap on dev NVMe0 N2P6. No label, and that is okay. Next, we need all of this stuff in etc fstep. BLKID is showing me all of this stuff, and you know what? I'm using BLKID. BLKID pipe till minus 3 pipe awk print $2. Is that giving me the result? Yeah, that is giving me the result, and that is what I want in etc fstep. So I have them in order here, and now I can go into etc fstep and I can do my things. So UUID equals, this is the first partition. The first partition, that was ext4, and we need it on /mount/files and defaults and defaults in 00. That's what we always get. The second one, that was my my swap partition. Swap is mounted on none, and we call it swap, and then we do defaults and 0 and 0. And then we have label is my XFS. That is XFS, and we mount it on mounts XFS and defaults and 0 and 0. Now, what would you do next on the exam? Well, if this would be the exam, you need to do things. Mount -A to verify that you didn't make any typos. And oh boy, I made a typo. Mount ext4 mount point doesn't exist. What is going on? I made a very stupid mistake, as you can see, and the mistake is that I have my file system in the second column. That's what I really don't like with these long lines. The columns are no longer in order, and that's the reason for my mistake, but fortunately mount -A is telling me about it. So for none and swap, it was going all right. Here, it wasn't going all right. So here I need ext4, and I need XFS, and then I can do my mount -A again. Do you see how important mount -A is? And next, swap on -A is doing the same for swap. And just to make sure, for your own ease of mind, please reboot. You know why? If it's going very wrong on the exam, it's after editing your etc fstep. And if you have just made all of these file systems, how big are the chances that you overlooked something? Well, that's very real. And I would say make sure that you reboot so that if it is going wrong, you know where to go for the troubleshooting. If you don't reboot and you only reboot by the time your exam is almost over and then you discover issues, well, then you're in a difficult situation. Try to fix it in the limited time remaining. That might be the reason why you fail your exam. And that's the reason why I'm asking you reboot once you are done with all this partitioning stuff. It will make troubleshooting so much easier. All right. Folks, are you still with me? I hope you are. I hope this, I know this partitioning is is complex stuff. I'm going to slowly move over to the program of Day2. And in case you are wondering, oh my goodness, Sander, you are running behind. No, I'm not. I always am 1.5 hours down to Day2 when we are at this point. So no worries about it. I got it. If you still have any questions, anything unclear, please ask. And if you are okay, I do appreciate the thumbs up or something else in the group chat. You know, my worst nightmare is that I'm talking to my screen all day and nobody is getting back. And then I wake up screaming just to find out that I was disconnected from the internet since the early morning. That's my nightmare. And you can help me not to live my nightmare by being interactive every now and then. Your questions are more than welcome. Your questions are the difference between me sadly talking to my computer screen and me working with real people. Or just a thumbs up, that's good as well and much appreciated. Software, processes, networking, system D, boot procedure. I don't promise. I might shift topics a little bit here today. Depends on my mood. But first, we need to talk about software. Do you remember that yesterday I told you, please do not install any software before we have covered managing software? And that is for the following reason. The exam RHCSA, obviously you are going to do it on Red Hat Enterprise Linux. When you install Red Hat Enterprise Linux, then the first thing you need to do, you need to register. Register means that you are going to use your Red Hat entitlement to connect to the Red Hat Cloud, previously known as the Red Hat Network. And after registering, you get access to repositories. The important thing is no registering equals no repositories. In order to register, you need to be online. And I can tell you one thing, even if you take the home exam, which is fully online, the exam environment itself is not connected to the internet. On the exam, you cannot go on the internet because you're not connected. And if you're not connected, can you access repositories? Well, the answer is a simple 2-letter answer. It starts with an N. So no, you cannot access repositories if you are not on the internet. What does that mean? Oh my goodness, that means that you have no repositories. That also means that you can't install any software. And that means that you absolutely need to know how to configure your system as a repository client. The situation to expect on the exam is that there is a repository that is provided. On the exam, well, if you're not connected to the internet, they need to provide access to some repository. So there must be some statement like, hey, a repository is available at, and then you get a URL, okay? In Red Hat courses, that will be the classroom server. On the exam, that might be the exam server. I have sad news for you. We don't have a classroom server. So in my demo, I am going to explain 2 different things. First, I'm going to tell you how to create a repository based on the installation disk. Secondly, I'm going to tell you how to connect to the repository as a client so that you can install software. And that's what we need to do here. Understanding RPM packages. Okay, we have these slides. Let me tell you about it just to make sure. So software on RHEL is installed using packages. These packages are in the Red Hat package manager format. RPM, that's really an archive with some metadata, and this exists since 1994. So pretty old, pretty powerful. Now, packages, software packages have dependencies, and in order to manage dependencies, Red Hat use to install software from the repositories based on RPM packages, you use DNF. DNF is the updated version of Yum. Let me tell you a secret. Doesn't matter if you type Yum or DNF, it both works. But I like to be consistent with the latest and greatest, so I will be talking about DNF. You want to type Yum, that's okay. Even on the exam, you won't pay the price of missing any points. Now, once your packages are installed, they are registered in the RPM database. Why is that useful? Well, if you have a database with your packages installed, then you also know about package versions, and it makes it so easy to uninstall, to list installed packages, to manage updates, and so much more. So having this database really is cool. Okay, let's talk repositories. So what is a repository? Well, a repository in software management is a collection of RPM package files with an index that contains a repository contents. And these repositories often are offered through websites, but you can also have local repositories. We are going to create a local repository. The fact that we have a local repository doesn't change anything, because you use a URL to get to the files in your repositories. And who cares if it's local or if it's on a fancy website? Now, DNF is the default command. And DNF, yeah, this is Red Hat marketing. I repeat my previous statement. I don't care if you're using DNF or YUM. It's the same. Do an ls-l on both of the binaries, and you will see that both YUM and DNF are symbolic linked to the same binary. Good. As I just told you, we need a repository. This is a bonus topic. This topic is something you will not see on the exam, because on the exam they will provide an exam server that you can use as a repository server. I will first show you how this local repository is installed, and later I will tell you how using a repository on the exam is different from what we are doing here. It should be pretty obvious. Now, this procedure, it's important to check available disk space. So very first I'm using df-h. And in df-h, we are checking the available disk space in the root volume. We need 10 gigabytes or more. If you have 10 gigabytes or more, you are going to follow the procedure that I'm demonstrating right now. If not, you follow you use the last two lines on the slide. The procedure is, I'm going to clone my installation ISO to a local file. Installation ISO is big, so I need a lot of disk space in my root file system. The reason I'm cloning the installation ISO to a local file is that it removes the dependency to the installation ISO. You know, your installation ISO might not be available, and then you don't have a repository, and that's why I don't like mounting the installation ISO directly, which is what we do in the last two lines. Okay, let me start by doing lsblk. And in lsblk, I'm looking for SR0. SR0 is the device name of my optical disk, which, excuse me, which connects to the installation ISO. Using ddif is dev SR0, of is /rel9 ISO. BS is 1M. DED is a fantastic command. It stands for convert and copy. Unfortunately, CC, the C compiler, was already using CC. So the DD folks took the next letters available in the alphabet. And that is why it's called DD and not CC. IF stands for input file. So the input file is my CD-ROM device. OF stands for output file. That's the file that I'm writing. So I'm writing the file rel9.iso. And BS is 1M. And BS is 1M is indicating that I want to use a block size of 1 megabyte. Without the BS is 1M, the command will be very much slower. Really, it can take 15 minutes without BS is 1M, also depending on the speed of your storage, of course. But by default, DD is streaming bytes. It's doing it byte by byte. And by using BS is 1M, it's doing it using blocks with a size of 1 megabyte. And as you can see, 9.6 gigabytes was copied after 30.9 seconds. Well, that's what I call acceptable. Let's use ls minus l on slash, and there we can see rel9 ISO is copied in the root file system. That's good. Now I need to make sure that we are going to mount it. So mkdir/repo. And I'm not going to do the fancy stuff on the slide. I'm going to do the boring stuff. I'm opening etc fs tab in an editor. And I'm adding, once again, a new line to etc fs tab. What is the line? Well, that is rel9.iso. So normally in the first column in fs tab, you would have a device. Now instead of a device, I'm using the ISO file. I want to mount the ISO file on /repo. I want to use the ISO 9660 file system. That's a special file system. You need to use it to access files from an ISO file or from an optical disk if you want. Then I need defaults for my mount option and 0, which is what we need most of the time. And now that I've got this in my etc fs tab, I can use mount -a, and it's giving a warning, mounted read only. That is okay. As a test, if I'm using ls on /repo, I see content, and the content is the content of my installation disk, and that's exactly what I want. Once again, if you do not have 10 gigabytes of available disk space, or if you are now getting lots of error messages because you just filled up your entire disk, remove it and do it again following the last two steps on the slide. So instead of mounting the ISO, you would use dev sr0. But you will need to make sure that dev sr0 is connected all the time. Just be aware of that. Okay. So that concludes how we are setting up a local repository server. Now we need to talk about accessing repositories. This is the part that is really important and the part that does matter for the exam. So if you want to access repositories, as I already told you, normally the RHEL system must be registered using Subscription Manager. Subscription Manager tries to access the online Red Hat repositories, and as an alternative to online, you could also use Red Hat Satellite. You won't have either of them on the exam. And the result, and I use RED because this is so incredibly important, the result is that if no internet connection nor Red Hat Satellite are available, no repositories will be available by default. No repositories means you can't install anything. And I can tell you one thing, if you cannot install anything on your exam virtual machines, you are most likely going to fail your exam. So this is a critical skill. But there's an easy solution, and the easy solution is to do manually configuration of your repository access, and that is what we are going to do. So how does that work? Well, a repository access is configured through repo files. The repo files are in etc.yum.repos.d, or you use DNF config manager. If you are old school, you probably want to create the repo files yourself. If you are not old school, I would recommend use DNF config manager because it's really an easy to use command. How difficult is it? Well, DNF config manager --add repo is what you are going to do. Now, I need to tell you a little bit about the repository. So back to the contents of this repo directory. What do we find? We find that we have two different repositories, AppStream and Base OS. If you do an ls, let me go in there, it's easier. If you do an ls on Base OS, that has a subdirectory, uppercase P, subdirectory packages. And you can find all the RPM packages that are a part of the core operating system. Likewise, in AppStream packages, you have additional packages. Why did I change directory? For no good reason, because I wasn't thinking. But what you need to know is that in order to get access to all of these packages, you need to provide a repository for Base OS as well as for AppStream. and that is what you see here. So I'm going to do it immediately. DNF config manager minus minus add repo is file colon slash 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 repo slash base OS. And I'm going to do the same for AppStream. Now, if you are thinking what a weird URL that is, file colon slash slash slash, yes, because in the URL we have two components. Component number one is what we call the URI, the Universal Resource Identifier. And the Universal Resource Identifier is written as protocol colon slash slash, like HTTP colon slash slash or HTTPS colon slash slash. That's what you will use in most cases. Now, if you are accessing a web server, next you specify the name of the web server and the directory that you want to access here. Here we are specifying a URL that points to a file on my local system. And the URI in this URL is followed by the path. And a file path happens to be starting with a slash if it needs to be an absolute path, and that is absolutely what it needs. So the three slashes are not a typo. They are exactly what we need here. Now, at this point, I should be able to use DNF repo list. And DNF repo list is showing me the two repositories. So that is looking so good. Let's get back to the slide for a bit. What do we find on the slide? Here we can see what you can also do. You can also use an editor. Oops, what am I doing with my red pen? You can use an editor and create the configuration file for yourself. Let me show you. In etc yum.repos.d, that's where you will find your repository files. My DNF config manager command has created two files. Cat repo base OS, here we can see the content of the base OS file, and cat repo AppStream, well, that's kind of the same. STL, in the exam, you must substitute this URL with the provided URL. So on the exam, you are not going to use file colon slash slash. You are most likely going to use something like HTTP colon my server slash base OS. Something like that. That is what is going to be different. All right. So again, this is essential stuff on the exam. You really must make sure that you know how to do it. So now I have my repositories. Does that mean that I can do DNF install? DNF install minus y nmap. Oh boy, that doesn't look good. You know, if you get a lot of output like this, then the command is confused. And this is my command, and it's telling me after this system is not registered, it will complain about the registration forever. That's just a fact. But next it's telling me you have enabled checking of packages via GPG keys. What is the GPG key? Have a look at the slide, because I'm explaining this on the slide. So to make sure that packages have not been tampered with, GPG keys can be used. That's pretty important, particularly if you're installing packets from the internet using root privileges. You have these repositories, and to protect you from man-in-the-middle attacks, when you connect to a repository, the repository has a cryptographic signature, and this cryptographic signature is a GPG key. On first contact with the repository, it will tell you, hey, you've never worked with this repository before. Do you want to install the GPG key? The appropriate answer is yes. But in order to do so, you need a repository that has a GPG key. Now, the thing is that I do not have the GPG key on my repository, and also I do not want to install a GPG key for my repository. Even if in real life that would be interesting, In our context here, that is way too much, way too complicated. So we need to tell the repository client that it should skip this GPG stuff. And that's what we do by using GPG check is 0. Now the easy way, and I repeat that I'm stressing on the word easy. It's not the only way. I am going for the easy way here. And the easy way to provide this information is by editing the file. At least that's what I consider the easy way. This repo underscore base OS has everything I need, and I am going to add GPG check is 0 to disable GPG check. So this is what you do for private repositories that do not have GPG key. In a real life, you might want to consider even giving your private repositories a G key, but this is not real life, this is exam, and the exam is all about survival. So GPG check is 0, and I have that for all of my repositories now, and that means that I can try my DNF install again. Oh yeah, one little tip. Out of habit, I'm using DNF install -y. -y is automatically answering yes. You might want to consider skipping the -y on the exam. Because if you made a typo while you are trying to install a list of packages, then in the summary of what it is going to do, it will be very clear that you made a typo. If you use -y, then it will automatically continue and install the packages that were not problematic, and you will not be aware of the packages where you made a typo. So consider skipping the -y to avoid confusion. With the disadvantage that you need to type it manually, which is what I'm doing right now. And yeah, it starts installing the package, and it has installed the package, and it's working. Oh yeah, good. So now we can manage packages with DNF. I don't think I'm going to separately tell you about all of this. Yeah, this one is nice. DNF list. Sometimes you might wonder, which package do I need to install? Then I like DNF list SE Linux star. What is that doing? Well, you can guess what it is doing. It lists all packages that have a name starting SE Linux. And it even indicates if it has already been installed or if it is still available. So if you are missing some packages, this can be a way to figure out which package you need. What I also like is DNF provides /SE info. I'm looking for the package that has the file SE info. And there you can see that it has found SE Tools console. Now you might think, Sander, if you type SE info, then it will automatically prompt you, install package SE Tool console to provide command SE info. That will be a solution for binary files. The nice thing about DNF provides is that DNF provides works for any file. Like DNF provides Docker file. Just imagine that somewhere during the exam you need a Docker file or a container file. How are they calling them nowadays? Well, if you need an example of a Docker file, then here you can find that this is in Rust src. So you would install Rust src, and then you have your Docker file. DNF provides is very powerful. TL, you're asking also, is it necessary to mount in the exam? TL, I don't understand your question. Be more specific. Because if I read the question as it is, then I would say, of course, you need to know how to mount devices. But I think your question is related to repositories, but I'm not sure how exactly. And B wants to know, does quoting matter, single versus double? Not in this context. As you can see, your question was about the DNF list, and DNF list works with double quotes and single quotes. Yeah, if your repository is an online web server, How do you want to mount an online web server? So no, mounting is not necessary here. Mounting is necessary as I'm using my installation ISO as a repository. And for that specific case, it must be mounted. Yeah, TM, you are giving generic explanation of the double quotes, which allow for variable expansion. We don't have any variables here. It's just a wildcard. And no matter if it's a single or a double quote, it just works. DNF provides, remember that, that's your friend. DNF search is not as powerful. I really like DNF provides. And for the rest of it, how do we manage? Well, DNF install and DNF remove and DNF update to update packages, DNF update -y to update everything, or DNF update kernel. That's an interesting case. DNF update kernel will install a newer version of the kernel that is, if that is available, and it still keeps the older version of the kernel. So that in case of trouble, you can always get back to the older version of the kernel. Sometimes that is necessary. And B, you want me to type history. Here we go. If you just miss a command, folks, it's just one thing you need to do. Just type the word history, and I know what to do. Right, continuing on the slide, understanding groups. DNF groups, that's not an F. DNF groups list is doing what? Showing package groups. These package groups make it easy to install specific functionality. So if I would want to install a virtualization host, for instance, I can use DNF groups install. Use double quotes virtualization host, and that will install all packages that make my server a virtualization host. Now that happens to be 1.3 gigabytes in total. That is not okay. I don't want to do that because it will be doing useless work for a long time, consuming disk space that I might need for something more important later on during the procedure. OA is asking, is it okay, advisable to update system at any point? On the exam, you mean? No. On the exam, if they don't ask, don't. That's the simplest statement I can make. So don't do things because at work they think it's good to do. Only do things when they ask you to do it. Also on the exam, most likely your software isn't a candidate for any updates or whatever. GEC wants to know, is there a way to get the group package that contains the file instead of just an isolated command? I would like to get from DNF provide /Scopio, not Scopio RPM, but container tools RPM. I'm not sure how to do that, GC. AS, you missed DNF groups list. Look, DNF groups list. These are the groups. And virtualization host, that's right here. And all the other keywords, well, DNF groups list, that's how I got there. You know what I think we are going to do? Let's check. Let's check if this lab makes sense. Ensure your system is using a repository. Yeah, that makes sense. Find the package that contains SE info and download HTTP package from the repositories without installing it and query to see if there are any scripts in it. The last one might be challenging because I did not explain. But hey, we are going to do a break. And I think the first two parts are critical. You must make sure that you can use your repositories. The last part is not very critical. Just consider that a bonus part. I need you to make sure that your system can use repositories, and that is what we are going to do now. Well, no, you. I am going to make coffee. So you have probably been following along. And as you have, you don't need that much time now, do you? So, how much time am I going to give you? Well, I'm going to give you 13 minutes in total. Hey, I am going to answer your question. Folks, consider this issue installing yesterday, and it only worked with minus minus no best. I am guessing that this is the result of you first registering your system and installing packages from the internet. Next, you following my instructions and creating a repository server that uses files that are on disk. And then you are going to install files from an older repository while you already have dependencies from the newer repository. So I guess your problem is you messed it up. And SJ, you have registered the system. SJ, use your 712 seconds to install a new system. This is critical stuff. You must practice it. If you have registered your system, there is only one way. Power off, delete it, and go have fun installing a new one. Folks, sometimes if I repeat things like 5 different times and tell you, really, you shouldn't do this, then really, you shouldn't do it. It is important to listen to what I'm saying. Sorry, SJ, but nobody can say that I haven't been very, very, very specific about it. It's the only way. And yeah, sorry. I go make coffee. See you in a bit. Hello, folks. I'm back. And let's continue. Good. Hey, thank you so much for providing the solution in the group chat. And your solution is looking quite all right. Now, what I wanted to do in this lab, I wanted to make you aware that even on the exam, you might get surprising questions. And this is a surprising question. How do we download an HTTP package? Man DNF, and in DNF, do we have any option for download? There we have download and download only. So that seems to be it. So download only, that's download to resolve package set without performing any RPM transaction. So packages are removed after the next successful transaction, and to persist the package, use the download command. So DNF download HTTPD. And what do we get? We get HTTPD in the current directory. You are using a destination directory. Destination directory is allowed, but it's optional. It's not really required. And now I have downloaded the package, and the second part, query to see if there are any scripts in it. So how do we query a package file? Well, that would be RPM-Q. That's a generic option for query. If you just use -Q, you would query the RPM database. Now, I don't want to query the RPM database. I want to query the file that we have just downloaded. And that's why I make it RPM-QP --scripts on HTTPD and so on. RPM queries are powerful. They allow you to investigate the package before you are going to actually use it. And if you want to see if a package contains any scripts, that's definitely worth investigating. Because when you install a package, the package runs with root privileges, and that means that also the script runs with root privileges. And we can see that we have a post-install scriptlet and we have a pre-uninstall scriptlet. These are the scriptlets, and this is how you can investigate it. I repeat my statement. Regardless of how hard I try to teach you everything in this class, there's always a chance that on the exam they're asking for something that you don't know about. Like this, and that is where it all comes down to your skills in using man and man-K and stuff like that. I don't want to do processes right now. We'll do processes later. I do want to do networking. I'm going to do networking, the short version, right now. Two things about networking, and everybody listen fast, because in 5 minutes we will be done with the networking. First, you need to be able to investigate your current networking. How do you do that? By using IP-ADDR show, which will show your current IP addresses. If you are too lazy to type IP-ADDR show, alternatively, you might want to use IP-A, which is giving you the exact same result. Now, what you see is LO. LO is loopback. And ENS160 is your real network card. Your real network card, that's a network interface that connects to some wiring or even wireless. And on that network interface, we can see the INET address. Some of you might still use the old command ifconfig. And you might say, what is wrong with it? Because it looks okay and it's even nicely formatted. Well, what is wrong with it is this. If I use man ifconfig, then man is telling me this program is obsolete. It has been obsolete only since 1998. That's 25 years ago. Yes, that's correct. You should really not use ifconfig anymore. I don't want to spend too many words on it, but if you are using ifconfig, you might miss vital configuration information about your network. So IP-ADDR show is the only way to get a reliable overview of your current networking. Use it. Now, in RHCSA, you also might be asked to configure your network. And how do you do that? Well, you use NMTUI. Now, folks, I know there's this fantastic utility, NMCLI. NMCLI is very powerful. And because it's so powerful, it's also pretty complex. And for that reason, I'm saying don't use NMCLI if you just need to set a network, an IP address on your network interface. Just use NMTUI because it allows you to do it within a very short period of time. So NMTUI is the text user interface. And yes, I agree, this looks like MS-DOS did in 1993, but that doesn't matter. It's a very functional utility where we have added a connection. So I'm going to edit a connection. I see ENS160, that's my primary network card. I am using edit, and then we can see the options. IPv4 is set to automatic. Automatic means go get it from a DHCP server. I'm pressing enter, and if I want to change that, I can set it to manual, and I'm using change, and next I'm using the address, and I am going to add 192.168.29.11/24. Make sure you use an IP address where you really know that it's going to work. Well, this would work. We also need a gateway, 192.168.29.2. And we need a DNS server, 192.168.29.2. If you need to do stuff like this on the exam, there's only one option, and that is that on the exam they tell you about the addresses that you are going to need. Next, I'm scrolling down, selecting OK. This will write the configuration, and after writing the configuration, we need to go activate the connection. How does that work? Well, select activate, press enter. Now it's deactivated, and press enter again to activate it, and then back, and then you are done. And oh, by the way, you can also easily set the system host name from here. I'm not showing you. You should be able to do that yourself. I said I'm not showing you. I want to quit. And I want to do IPA. And what do we see? We see 192.168.29.11. Hey, one more thing. What is this NMTUI doing? Well, NMTUI, the text user interface, is configuring the network manager. And network manager is a service that is managed by systemd. On RHEL 8, there was this discussion about it. On RHEL 7, there was this discussion about it, and some people disabled Network Manager. On RHEL 9, disabling Network Manager is no longer an option. So the only thing you need to know about it is systemctl status on Network Manager to verify that it is up and running. Now, services in systemd normally are all lowercase. There's one exception, and that's Network Manager, uppercase N, uppercase M. JS is asking, what kind of stuff will they ask about networking in your certification class? You had us to do port forwarding, and I was stumped. Well, JS, on the exam, you need to be able to configure a network interface, and your RHCSA level firewalling is pretty basic. The reason JS said on the certification class I had port forwarding is that is something that you need to know if you are doing LFCS. And hey, in the certification class JS, one of the missions was to teach you beyond the exam requirements. GC, if in the exam they give me the mask 255/0, am I supposed to resolve it as /24? GC, I have a hard time believing that you are that they are giving you the 255 etc. Subnet mask, because that is deprecated since 1971 or so. No, I'm kidding. It's not so long ago, but I'm not expecting the exam to be about your abilities to convert a dotted subnet mask into a CIDR subnet mask. So that is not likely. TL is asking, is IPv required for the exam? TL, what you need to do is have a look at the RHCSA objectives. Folks, I want to do that right now. And JS is following up. I'm going to start the browser first time, always takes a little bit. JS is asking, do we need to know any of the NMCLI commands or switches? JS, I repeat my previous statement. The exam is not about which utility you are using. The exam is about the solution that you are providing. And anything that you need to do according to the RHCSA objectives can be done using NMTUI. You know, folks, in this class, I take my mission pretty seriously. And when I cover a topic, I want to cover it in a way that helps you deal with the topic on the exam. So if I say NMTUI is sufficient, then NMTUI should be sufficient. And here we go, RHCSA objectives. I am going to the Red Hat website. Yeah, JP, that's exactly what I'm wondering. I know that Ubuntu sometimes has this weird habit of doing very legacy stuff, but on Red Hat, I just can't believe that they are going to ask you about non-CIDR subnet mask. Folks, here are the objectives. You probably can Google yourself, but just to make sure, here is the link. Study this and have a look at it. Also a week before you go on the exam, because sometimes the objectives do change. And I'm scrolling through it to see if I see anything that relates to networking. That should be here, I guess. And it said, oh, manage basic networking. Yeah, configure IPv4 and IPv6. In case you are wondering now, hey, Sander, are you going to teach us any IPv6? My answer is no. Don't ask me any questions because I don't want to violate the NDA. But I do want to repeat my statement that I take these exams and I'm making sure that based on my classes, you can pass them. I have some IPv6 in the recorded video course if you really want to know about it. And JS, you're asking about the SS commands. No, JS, that's not how it works on the exam. On the exam, they don't tell, no, I don't think there's one single case. Oh, there is a case, task scheduling using @ and cron. Normally on the exam, they don't tell you which commands you need. That's LPI. In LPI, you get a list of all the commands you need to know about. The RHCSA exam is about tasks that you need to be able to do. So that's not about SS. You should be looking for an objective like analyze ports that are currently offered on your system. That would be SS. But yeah, neither of these are in the objectives. I hope that was a little bit helpful, even if I'm bound by this non-disclosure agreement. This was our topic, managing networking. And what are we going to do now? Yeah, let's do systemd. Hey JP, you like posting links. Can you please post a link to my RHCSA video course for whoever, MB. SJ, you say I can configure network using GUI. And well, SJ, if you want to configure network using GUI, you need a GUI. Need I say more? I hope not. And yes, the fun thing is that when I started IT, networking was a big thing, and everybody was explaining networking. Nowadays, everybody assumes that people learned about networking at school, and There is not really a good live course that teaches IP fundamentals, but I think there is an IP fundamentals recorded course. Check it out. If you have a hard time finding it, tell me. I'll try if I can find it for you. But that should help in getting some basic understanding of what it is about. And thanks AA for posting the link to the RH-CSA 9 course. Folks, I'm going to tell you about System D. And the fun thing is I have a 5-hour class about System D. We are trying to schedule it for February, but that's still a long time. So for now, you will need to do with the short lecture about System D that I'm going to give you right now. What is System D? System D is the manager of everything on your Linux system. We are moving a little bit more towards the boot procedure and how we are starting and managing services and so much more on Linux. In order to manage everything, System D uses units. And folks, just for your information at this point, it really helps if you follow along on the slides, because I'm trying not to get distracted too much about System D, because before you know, I'm talking about System D for the rest of the day and tomorrow as well. We don't want to do that. So System D units. What is a unit? Well, the System D unit is the thing that is managed by System D. And you know what? Let me use systemctl. I'm trying to demo and do slides at the same time. Systemctl has awesome tab completion. Yesterday, there was a talk about how do I remember all this stuff. Well, try to remember as little as possible. Use tab completion. Like here, for instance. Systemctl has tab completion, and if I don't remember how these units can be shown, then systemctl list units. These are all the units that have been started by Systemd. These include devices. Yes, my friends, device management is included by Systemd. These include mounts. The fun thing is that Systemd reads etc fstab, converts it to a mount. These include services as well. For the remainder of this talk, I'm going to tell you mainly services. But you should be aware that in Systemd, many different unit types can be used. So yeah, units, and if you want an overview of these units types, systemctl -t help is showing you all the types that are available. So what do we see? We see all of this. These are the unit types. So we have services, that's for processes. Mounts, that's for mounts, taking over etc fstab. It can manage swap as well. Target, and yes, I'm skipping a few of them. If they are really not important, I'm skipping them because we don't have the time. A target is a group of units. We have even timers, which is basically a cron job. And so much that can be managed by Systemd. And thank you, JP. There's even a live class on December 8th. I love it. I didn't know there was a TCP/IP fundamentals live class. I know the author. He knows his stuff, and I can recommend it. Good. Back to Systemd and the unit types. So service units are used to start processes. Oh, here on the slide, I'm explaining the unit types anyway. Hey, let's go over it. Socket units monitor activity on a port and start a corresponding service unit when needed. So you can tell Systemd to listen on port 80, for instance, and automatically start your HTTPD service when traffic is coming in on port 80. Timers have taken over cron jobs, and they are used to start services periodically. We'll talk about timers separately and also about cron jobs, because you may just have noticed that cron jobs are still in the RH-CSA objectives. There's even path units. A path unit can start a service when activity is detected in the file system. Let me give you an example of how that is useful. Think about print servers. A print server typically reacts if a file is dropped in a printer spool directory. So what would you do? You configure a path unit, and if a file is dropped in the path, the file system path specified by the path unit, you start the corresponding service unit. Mount units are used to mount file systems. We can mount file systems without FSTAP, and other unit types are also available. They are not really relevant for RHCSA. What is relevant for RHCSA is mainly the service units. So service units are often used to start daemon processes. And these daemon processes are the processes that are listening on your system for incoming activity. Other types of service units also exist. You can create a service unit that runs a simple command like sleep 60 for which goes to sleep for 60 seconds. In a service unit, you can define type is simple to start any command through systemd. And good, here we have demo number 1. Well, I already have shown most of this, right? I have only not shown systemctl list unit files and list units. Okay, a couple more. Systemctl list unit files. So when you use list units, you're talking about actively running units. When you use list unit files, you generate a list of all the unit files that are available on your system, including their status. And that is showing that we have a Podman service currently disabled, and we have RHCD, which is currently disabled. What it is, I don't know. I don't care. I just want to know. I just want to make sure that you know how you can print a list of all of these. Now, I am going to install something. So let me do dnf install -y httpd. I'm going to install the httpd web service. Now, the httpd web service comes with its own systemd unit file. So let's use systemctl status httpd to figure out what this thing is doing. And this is a key skill. So what do we see? We see httpd service, Apache httpd loaded. This is about a configuration file that it is aware of. And loaded is means that systemd is aware of the configuration file right here. Disabled and preset disabled means that currently this unit is not set to be started automatically. And also inactive, we can see it's inactive and dead. I am going to use systemctl start httpd. There we go. Repeating my systemctl status, and look at that, now it is active. But it's still disabled, which means that if I'm going to reboot, it won't come up automatically. And this is very important if you are going to install one of these services. You should always use systemctl enable to automatically start it after reboot. Is that it's providing much information about the process ID, like the memory it uses, and also recently logged messages. That's because systemd includes systemd journald. Systemd journald is a logging service, and this logging service catches messages that are generated by anything in systemd. And that is why systemctl status can easily show you these messages. Okay, DM wants to know, what does static mean? Static means that it is managed by the operating system and statically gets its status, so not really intended to be managed by people. Back to the slides, systemd unit management tasks. What do you need to know about this unit management? Well, you need to know about just did. And there you can see active, which shows the current status, and loaded, which shows the configuration file that is loaded. And systemctl start will start the unit that is not currently active, just demonstrated. You can imagine what systemctl stop is doing, right? And systemctl enable will flag the unit for automatic starting upon system start. And if you're looking at the unit that is not currently running, use systemctl enable -- now. That will automatically start the unit. It will flag it for automatically starting, and it will also run it right now. And that's sometimes what you want to do. The counterpart of that is systemctl disable. That will no longer automatically start it after restarting your system. Also interesting is systemctl reload. Systemctl reload will reload the unit configuration without restarting the unit, and systemctl restart restarts the unit, after which the process it manages gets a new PID. Now, this might be a bit complex. When is systemctl restart required? Well, systemctl restart is what you want to use if you changed the configuration of the unit. So if you are talking about SSHD, there is a parameter that you can use to decide whether or not the root user is allowed to log in. That's in the SSHD underscore config. You change the parameter, you need a restart. And then there is systemctl reload, is what you use to tell systemd to reload its unit configuration. I need to demonstrate this. Let me use systemctl cat sshd.service, which is showing me user lib systemd system sshd.service. So this is the configuration file that I'm currently looking at. This is what is happening when I'm using sshd.service. I am going to change the parameter, and I'm using systemctl edit on sshd.service to change it. Even if behind systemd there are configuration files in this user lib system, etc., don't change the configuration files directly. Use systemctl edit. And that brings me in the configuration where I'm going to use service, and I'm setting service to restart. Sec is 21S. Now, the specific modification I'm making is always overwriting the generic setting. So from now on, restart sec is 21 seconds. Should make sure that this service is going to be restarted after 21 seconds if anything is going wrong. I'm using Ctrl X to quit this terrible nano, and yes, I want to save the modified buffer, and I'm pressing enter, and now the change is there. Now, this is what systemctl reload originally intended to do. If you want systemd to be aware of this new parameter, use systemctl reload. That will tell systemd to reread the configuration. But systemctl reload really was relevant in older versions of systemd, because if right now I'm using systemctl cat on sshd.service, what do we see? We see that the new parameter is already there. And for your information, if I'm using systemctl quick demo, and then I will demonstrate a question about the -- now as well, systemctl status sshd, I'm going to use kill -9 on 1108. That's the SSH process. Now I'm using systemctl status. And what do we see? We see it is activating auto restart. Configured systemd to automatically restart your processes if ever they were failing. Now about the -- now. What is this minus minus now all about? Well, let me use systemctl status HTTPD. We can see that it is enabled, it is active. I'm going to use systemctl disable HTTPD. And I'm using systemctl status again. And what do we see? We see it is disabled, but it's still active. So I need to separately use systemctl stop HTTPD. Now the thing is that enable and stop, disable and stop, and enable and start are two separate commands. You might not want to run them as separate commands, and that is why we have systemctl enable minus minus now. So systemctl enable minus minus now HTTPD will enable it and will also start it. And B is asking, will a restart also reload the configuration? Well, as I just told, the reload option is really an obsolete option. You don't need it anymore, because if you make changes to your configuration, it will automatically be picked up by systemd. So that is happening automatically as an independent process, and that is how it would work. Right. Let's move forward and let's talk about modifying systemd unit configuration. Hey folks, in fact, I already have shown you how to modify the systemd unit configuration. But it might help to go over it once again, so let me do that. So systemd works with default configuration files. These are in userlib systemd system. There's only one thing you need to know about files in userlib systemd system. Don't ever touch. They are managed files. They are managed by the package manager in your system. And you should consider that on an update, these files might automatically be updated. And that's why the custom unit files should be put in etc systemd system. This is, by the way, a generic thing that you will see a lot in Linux. So the standard stuff that comes from packages is in userlib. The customizations that you make are in etc. And etc is always overwriting, so it has a higher priority than the standard stuff in userlib. Apart from that, there's runtime automatically generated stuff. You don't have to deal with that too much. So let's not talk too much about run systemd. Now, when you modify a unit file, you don't edit the file in userlib systemd system. You create a custom file in etc systemd system, or even better, you are going to use systemctl edit. When I first used systemd in RHEL 7, the editing mechanism wasn't as good as it is nowadays. So what did we do if we wanted to customize? Well, we copied the standard configuration from userlib systemd system to etc systemd, and we edited the copied file in etc systemd. As the files in etc systemd are applied after the generic files in userlib systemd, they have higher priority, and that would work. But if you use systemctl edit, then what is going on? Well, let's have a look again at systemctl cat for sshd.service. And what do we see? We still have the standard file. We still have restart sec is 42 seconds, but by using the edit command, it has created etc systemd system ssh.service.d/override.conf. Excuse me. This override.conf contains your modifications, and your modifications have a higher priority. So this will override restart sec to be 21 seconds instead of 42 seconds. And that is how it works automatically. And as it works pretty well automatically, don't do anything else. we can skip this last bullet. System CTL reload may be required. Well, I can tell you, when I started creating these slides on RHEL 9, based on my previous experience, I decided to keep this information in. Since then, I've been using RHEL 9 a lot. I never, ever had to use System CTL reload. Likewise, you will read about System CTL daemon reload, so that the System CTL daemon reloads configuration, I never ever had to use that on RHEL 9. On RHEL 9, if you edit System D configuration, it's picked up automatically. Good. We have already done what is on this slide. If you feel like practicing, I have these demo slides. You will notice now that it's becoming a little bit more complex. Every now and then I have demo slides. Feel free to work through these demo slides on your own. Then there's a stupid thing, System CTL mask. Why is this a stupid thing? Because nobody ever uses it, but it's in the RHCSA objectives. So I need to tell you about it anyway, even if it's useless. What is System CTL mask? Well, some units cannot work simultaneously on the same system. Let's imagine that you have HTTPD and you have Nginx. Can you run HTTP and Nginx on the same system at the same time? Most likely not. Why do I call System CTL mask a stupid thing? Well, because instead of masking, you might also not install the competing service. That's a lot easier. But I need to explain System CTL mask, and you need to know about it. So here we go. How does it work? Well, if you want to prevent administrators from accidentally starting these units, you use System CTL mask. Let me try DNF install -y Nginx. I'm not even sure if there's an installation candidate. Yeah, there's an installation candidate for Nginx. System CTL status Nginx. That's a wild guess. I think it has a unit file, and yeah, it has a unit file, the nginx.service. Now, if you are going to try to start it, nobody is going to tell you that that's maybe not the smartest idea, but it will fail. And that is why I'm going to use System CTL mask Nginx. So it is here, and if you are going to try to start it, you are getting failed to start Nginx service, unit Nginx server service is masked. And if ever you want to return on that decision, you can use System CTL unmasked to unmask it. JP, no comment. You know me, you know me, JP. And thanks for asking, because it might help people who don't really realize how I'm talking. Yeah, JJ, that might be a reason. So System CTL mask links the unit to the dev null device. Let me show you that. Where do we have it? Here I have System CTL mask. Look at my system. And there you can see that it created a symbolic link. That's pretty smart. You know what it's doing? It creates etc systemd system nginx.service. What did I just tell you? Default stuff is in user lib systemd system. Here it creates etc systemd system nginx.service. Same name, higher priority. But it links this file to dev null. And because it is linked to dev null, it can never be started. And systemd is going to interpret a symbolic link to dev null in etc systemd system as, hey, this is masked, and for that reason it will deny starting the unit file, as you can see. That's how it works. And you need to know about it. You need to talk about logging. So on RHEL 9, you have two systems for logging. There is rsyslogd, and rsyslogd creates files in the var log directory. It's still operational on Red Hat Enterprise Linux 9 for the simple reason that rsyslogd provides features that are not provided by journald. Features like Oh, you are distracting me, JP. Well, I'm distracting myself because I'm reading what you are posting. So RSysLogD provides features that are not provided by systemd journald, like centralized logging, like logging to specific modules. To specific modules, that means that you can use RSysLogD to log messages to a database. So you still have these files in var log and feel free to use them. But apart from that, you have the systemd journal. Use journal.ctl to get an overview of everything that has been logged to the systemd journal. And this is in less, so use the spacebar to scroll down, use uppercase G to go all the way down and to find what is going on in your journal. But hey, most people don't use the systemd journal by itself too often. They just use systemctl status on the systemd unit. Why do they do that? Well, because you immediately see the information that you want to know about. Now, what you need to know about the journal is that the journal is not persistent. That means that when you restart your system, the old journal is gone after the restart and you can't get it back. Now, for RHCSA, it's important that you know how to make it persistent. So where is it? Well, it is on this slide, the need for persistency. This is important. How do we do this? Well, originally the idea was we don't need a persistent journal because persistency is taken care of by RSyslog. The thing is that everything that is logged to the journal is also written to RSyslog. So why would you want to make it persistent twice? But you might decide to disable RSyslog and just go for the journal. And if that is what you are doing, then maybe you want to make the journal persistent. So how are you going to do that? Well, that is through etc systemdjournal.conf, where you have a storage is auto option. And the storage is auto option is the default. And it's pretty simple. The only thing you need to do is create a directory with the name varlog journal, and that will make it persistent. And that's what you need to know how to do. And I'm going to show you right here. The procedure that I'm showing you is on the slide. So what is that? Grab storage just grab storage. That should be enough. In etc systemd journal.conf. And what do we see? Storage is auto. It's behind the hash, but that indicates a default value. So by default, storage is set to auto. Now I'm going to create a varlog journal. And if you think that magically something appears, well, ls-l on varlog journal, it's empty. Let me give you the easy solution. If you don't want to remember what I'm going to do right now, just reboot your system. After the reboot, you'll have a persistent journal, but maybe you want to make it persistent. Right, going to do that? Well, then you need systemctl restart systemd-journal-flush. And now if I'm using ls-l on varlog journal again, then I can see there's a subdirectory in varlog journal. That is your persistent journal. This is stuff that you need to know about for the exam. And that is why I'm going to present it as a quick lab. Again, we are going to combine break and lab. I won't make this lab very long. I am going to make it a 13-minute lab. Before I'm going to start the break timer, I'm going to check what we are going to do next. Yeah, folks, our next thing is going to be an important thing. After the break, I'll tell you about LVM. So if you think I'm going to stop early today because last hour is not important, I would say think again, last hour is important. That will be LVM. So for now, feel free to work on this On this lap, I will start the timer, set it to 13 minutes, and after these 13 minutes, we are going to do LVM. Enjoy your break, enjoy your lap, and I will see you in 777 seconds. Hello, everybody. I am back. First, I want to thank you. It's amazing to see how well the self-help on the group chat is working. So thank you so much, folks, for reaching out and trying to help one another. To you, SJ, you get file name to write. That is expected. That's a temporary file name, and that is exactly what it's supposed to do. So when you use systemctl edit creates an override file, and this override file is in etc systemd system httpd.service.d, and the name should be override. SJ, you should use systemctl cat to verify once your edit is done. All right, folks, LVM, and I want to make a drawing for LVM. So back to the drawing application. Here we go. And you should be able to see the drawing application now. So what do I want to make clear? I want to make clear how LVM is organized. To work with LVM. LVM is an abstraction of your storage, and the center of your storage is the volume group, also known as the VG. VG is the abstraction of all the storage that you have available on your system. Now, how does that work? Well, that works in such a way that you are going to add PVs to your VG. A PV is either an entire disk or a partition. These are the physical volumes. Physical volumes is PV. And the power of LVM is that you have resizable storage because of the fact that you are putting all your PVs in a VG. So the volume group is the abstraction of all your storage, and you create your LVs, your logical volumes, from the volume group. Like LV1 and LV data. That's not data, it's DDA. Do I care? No, I don't. And LV files and whatever. So it's three different levels. You start with the physical volumes, you put your physical volumes in the volume group, and then from the volume group you create your logical volumes. On top of the logical volumes, you are going to use your MKFS, and it's a logical volume that you are going to mount. We'll talk about it shortly. But first, we need to talk a bit more about the physical volumes. Your physical volumes can be complete disks. Your physical volumes can also be partitions. And you know what? You can even put your /dev/sdb5, which is a logical partition. You can make it a physical volume, put it in a volume group, and create your LVM logical volumes from there. Is that confusing? That might be a little bit confusing, but if you get how this works, then you get how LVM works. Right, before I'm continuing, I'm going back to the system, and I want to address what JB is asking. SC, to your query, I only have one comment, and that is you are doing something wrong. That's so lame as a comment, but it is how it works. You know what, SC and JB, I'm going to try to address your questions in one big demo. And JB, you have a reasonable question because I think I skipped the explanation of systemctl show. If I use systemctl show httpd.service, what is systemctl show doing? Systemctl show is showing all the all the systemd parameters that I can squeeze in. Like, for instance, OOM policy is continue. What is OOM policy is continue? I don't know. Let's do man systemd.directives. And I am going to search for OOM policy. This is a very, very common situation in systemd. You start by doing your systemctl show to find out which parameters can I set, and you are getting something where really you have no clue. So how are you going to figure it out? Well, you need the man page for the directive that you just found, and I just found OOM policy, and I still have no clue. The key is this man page systemd directive. Systemd directives is so awesome, and I can see that OOM policy is documented in systemd.scope as well as so I am going to do man on systemd.service, and I'm going to look up OOM policy. And there we can see the complete description of OOM policy. I don't want to talk about out-of-memory policies right here. I just want to say OOM policy is continue. That looks okay. I'm getting this from systemd.service, so OOM policy belongs in the service section. JB, I hope this part of the explanation addresses what you are mentioning. If you need anything else, feel free to post follow-up question. But in service, I'm going to work with OOM policy. SC, we are going to analyze now what systemctl edit is doing. So systemctl edit on httpd.service is opening the editor, and here we have this override file. Okay, I'm going to use my editor, and we just found that this belongs in the service section. It is important that you include the service section, otherwise you get an error message. So in the service section, I am using OOM policy is continue. Then I need to save this file nano style. And I know Nano is a terrible editor, but hey, this is how it works. This is what we need to deal with. So Control X to save it nano style. Save modified buffer, yes. And then name file name to write. Just press Enter. And check the file that has been written. SC, did you see that the file name to write was still prompting for this weird file name? Well, if I'm using ls in etc systemd, http etc systemd system httpd service.d, there we can see that it has created override.conf. Let me use Ctrl A to move the cursor to the start of the command line and show you the override.conf. This is the contents of the override.conf, and systemctl cat on httpd is showing that it now includes this override.conf. SC, verify your procedure with what I've just shown. Everybody, back to LVM. I am going to show you LVM. What are we going to do? Well, I'm going to get back to the drawing application just for a small moment. Because I want to fit the steps to what I just explained. First thing that I'm going to do, I'm going to take care of my physical volumes. I need to make sure that the storage device is available that I can fit in this volume group. And that will be a partition. So I'm going to start using the fdisk utility to create a partition. You can put a complete disk in LVM, you can put a partition in LVM, and I'm going to show you how to put a partition in there. That is also what you should count on for the exam. Next, as a second step, I am going to use pv create on that partition. You will see the details once I start demonstrating. I just want to outline. So step 1 and 2 are taking care of the physical volume. Next, in step 3, I'm going to use vg create to create the volume group. And in step 4, I'm going to use lv create to create the logical volume. Then in step 5, I'm going to use mkfs on my logical volume. And in step 6, I'm going to put it in etc fstab. And that is all. So it's a 6-step procedure, slightly complex. And it's important that you realize what is going on here. This is the foundation of an even more complex procedure, and that's the LVM resize, which I'm going to do later. But first, let's take care of just this. I'm back to you should see the demo system popping up about now. And I am going to do what? I'm going to use fdisk on dev NVMe 0 and 2. And before I do anything, I'm using P because we are changing partitioning. I want to see what is currently going on. Oh yeah, this is the one where we have a 19 gigabyte extended partition. I'm going to create a logical partition in the extended partition. And yes, my friends, I do this on purpose. This is confusing. A logical partition that is going to be used as a logical volume? Yes, exactly. I want you to fully understand what we are doing. And the only way to get there is to make this demo slightly complex. So N for new, and it's telling me adding logical partition 7 sounds good to me. And I am going to make that 2 gigabyte partition, so plus 2G will do that for me. And now that I'm here, I'm going to repeat this procedure immediately because I know that later on I'm going to need another partition. So N again, and enter for the first sector and plus 1 gigabyte to add another gigabyte. Using P for print. And what do we see? We see that partition number 7, partition number 8 are both using the Linux partition type. If you want to use your partition for LVM, that needs to change. How did we change partition types again? By using T for type. So partition number 7 first, and hex code or alias, I'm typing LVM. And likewise, T again for partition number 8, and I'm typing LVM and P to verify, and we can see NVMe 0 and 2P7 is now an LVM partition, and likewise for partition number 8. Using W to write and get out of here. That was step 1. Yes, JS, you get it. Van Gogh, that's also a van. I'm Van Vught, and that's also a van. I think we are related. You have noticed. You should see, hey, this is off topic, but hey, every now and then I like off topic. You should see the artwork that is going to be in my upcoming Kubernetes step-by-step. That's a video course that hopefully will be available somewhere February-ish. I'm currently developing it. And the fun thing is that I have found an awesome PowerPoint developer who creates awesome art, who happens to be my oldest son. I never knew that he was doing these awesome things. And he is really related to Van Gogh, if you see the work that he's been doing. I'm so looking forward to recording this project and doing something in a completely different way. That was an off topic. Let's continue. I now have 2 partitions. What's next? Well, next, we need to assign these partitions and make them PVs. Now, I will later tell you that we can do that automatically, but I want to make you aware of this required step. So I'm not going for the automatically approach, I'm going for the manual approach, and that will be PV create on dev NVMe 0 and 2P7. And likewise PV create on dev NVMe 0 and 2P8. And now if I use PVS, which is the command that prints all physical volumes, we can see that these 2 partitions show as a physical volume. Without this PVS, without this PV create, that would not have happened. So this PV create is really very important. So now we are good. And in case you are wondering what really happens if you use PV create, well, it writes a 16-byte metadata area to the storage device. That's not really what is important. What is important is that now they are flagged as physical volumes, and I can put them in a VG. So ready for step 3, which is VG create. VG create, and now we are getting into a little bit more complex stuff. The commands are getting longer, and before I'm typing my command, can we get any help? PV create minus minus help. And honestly, folks, I don't like the help that we see here, because I mean VG create VG new PV with all these options. Well, there's an easy way to start liking the help. All the options are between square brackets, and you know, if an option is between square brackets, you don't really need it. Anything between square brackets is optional, so feel free to skip this. And what remains is VG create, VG new, PV. So VG new is the volume group that I want to create, and PV is the physical volume that I want to put in this volume group. And you know what? That makes it, after all, VG create is not that complicated. But I need to get back. And I need to tell you about the most useless thing that I'm telling you about today. Is this as useless as system CTL mask? Well, maybe even more useless. I need to tell you about the physical extent size. If you don't do anything, you create a volume group, and this volume group is using physical extents, and the physical extent is really like a block. On a file system, the block is the minimal allocation unit. On a volume group, the physical extent is the minimal allocation unit. By default, physical extents are set to 4 megabytes. You can use -s to set a different size. So you know what? I'm even going to change -s 8M. That will create 8 megabyte physical extents. Data, dev, NVMe 0 and 2P7. There we go, volume group VG data successfully created. I can show you the summary by using VGS, and VGS is showing that I have VG data, 1 PV in there, and 1.99 gigabytes available and 1.99 gigabytes free. If you want to see some more detail about your volume groups and stuff, then you can use VG display. So let me use VG display on VG data, and what do we see? We see more information, including the PE size. PE size is the physical extent size. And we have physical extent size of 8 megabytes, and total PE is 255. And VG size is 1.99 gigabytes. And you know, something weird has happened here. Because if you have 255 physical extents times 8, how much is that? Let's calculate. Echo dollar double parentheses, 255 times 8 is 2040. We are missing Folks, I need confirmation. Can you still hear me?
Hi, Sander. We can still hear you.
Okay. I'm getting many people saying they cannot hear me. So video, yes. And apparently we had a small hiccup. Okay,
Yeah.
I'm back.
Okay. Sounds good.
Well, thank you very much for letting me know, folks. And I hope I was aware of this problem. soon enough. JR, you lost me for a minute or two. Hey, folks, can you tell me last thing that you that came through? Did my explanation of the physical extent came through? Folks, I need your feedback in the group chat so that I know where to pick it up. Yes, OV, we can start from 2040. Thank you very much. That is very useful. I just did my... So we have 255 P's, and the 255 PEs, that's the physical extent, and the physical extent size is 8 megabytes. And if you multiply that by using the bash command line calculator, you get a total of 2040. Now, the problem here is that we have a 2 gigabyte partition. So what happened to the remaining 8 gigabyte? Well, the remaining 8 gigabyte is used for metadata. And that's something you should be aware of. When you are creating a volume group, you lose one physical extent for metadata usage. Why is that important? Well, that is important for the next step, because in the next step, I'm going to use LV create to create a logical volume. LV create, I use it with a couple of options, minus N for the name.
Hey, Sandra, it sounds like you just dropped again. Hi, Sandra. I'm not sure if you can hear me, but it sounds like you dropped from the platform. All right.
Joan, I can hear you. That's good.
Okay. I can hear you again. Can you just do a quick browser refresh? Let's see if that helps.
I'm not sure at which point you can hear me again. And I'm back. Okay, I'm back. That's good. I'm on my other internet connection. Okay. It's frustrating. My redundant internet just failed on me. What is redundancy worth nowadays? Maybe it's because it's all a Wi-Fi and this one is wired, but shared. But I've been teaching on this internet connection for as long as I do this work, so we should be okay. And I am continuing. So let me repeat the LV create command. LV create minus N. What I was telling you, LV create minus N LV data. This is specifying the name that I want to assign to the logical volume. Minus uppercase L2 gigabyte. Which is specifying that I want a 2 gigabyte logical volume. VG data, that's the name of the volume group, so I want to create it from the VG data volume group. And then I'm getting this volume group has insufficient free space, 255 and 256 required. Well, we now know what is happening, right? It's because of the missing extent. Now, if you get a message like this, there are different things that you can do. You can use minus L2040M, for instance, to create a 2040 megabyte logical volume. Instead of specifying the megabyte, you can go for another approach as well. And in the other approach, you would use minus lowercase l 255. That's a little bit weird. But if you use minus lowercase l 255, you are addressing 255 logical extents. So there are different options. And yes, SJ, you can also use minus L 100% free. There are multiple options to revert the amount of storage that you want to use. But absolutely, SJ, the 100% free, is also going to work. All right. So at this point, I can use LVS. And when I use LVS, I see my logical volumes, which includes the LV data, VG data, and now I can use it. So I use my LV create. Now it's time for MKFS. So I am going to use mkfs.ext4 on /dev/VG data /LV data. The default names that I want to use for my logical volumes start with /dev, then we get the name of the volume group, then we get the name of the logical volume. So this is creating the logical volume. And this is creating the file system on the logical volume. And then the next step is going to be easy. I am going to put it in etc fs step. So let me first create the mount point LV data and then go into etc fs step. And in etc fs step, I'm going to mount it. So what is the device? That is dev data LV data. RM, I never said that we cannot use mkfs.xfs. I choose to use mkfs.exe4. You want to use xfs? Fine, go ahead. That's not what this demo is all about. I want to mount dev VG data LV data on /LV data, and I want to mount it as ext4 using defaults and 0 and 0. The more important question is, shouldn't we use a UUID? And the answer to that question is no. And that is because the information about the dev VG data LV data is stored in the device itself. So you don't need no UUID. If you are using dev VG data LV data, that's a name that's never automatically going to change. That is why also in the default configuration, you see LVM volume names directly. You don't see UUIDs. There's no reason to do this. So this will do it. And now I can use mount -A to mount it. And yeah, that is working. And now if I use mount, we can verify that it's there. Up to now, I've always used LSBLK because mount is giving me a little bit too much. But the device you just added is always added last to the list. And what do we see? Hey, do you see that? I mounted dev VG data LV data, and I'm getting dev mapper VG data dash LV data. Is that bad? Well, not at all, because ls-l on /dev /mapper /vg data LV data as well as dev VG data LV data is showing us what? It's showing us that both these names are symbolic links to a device with the name /dev/dm2. And this /dev/dm2, that's a device mapper device. Device mapper is a system that is used behind LVM. And the kernel talks to the device mapper, and that is why the kernel wants to work with this DM2 device. People don't want to work with this DM2 device, but this is how you see LVM. And by the way, sometimes the tool that you are using is showing you a DM device as well. And then you need to figure out what exactly this is coming from. RM, you want an explanation? You know what? You get your explanation about device mapper. If you want more advanced information like this, by the way, shameless plug for my next Monday course. Next Monday, I'm teaching Linux under the hood. Linux under the hood is Linux in depth. And in this Linux in-depth course, I do nothing but stuff that is going on behind your common Linux commands. I'm preparing for a new recording that I'm going to do early December of Linux under the hood. And that's why I'm test driving it a couple of times. So be there next Monday. You're going to love it if you like having more insight. In the meantime, I don't see my screen sharing working, so I'm going to try it again. Oh, that is so funny. In my preview window, I don't see the screen share working, but on my student view, I do see it. That is weird. And well, you can see it. That's all that matters. Folks, this is in-depth information you don't need to be able to reproduce on the exam, but having insight is always cool. Linux kernel is the part that communicates to the hardware. A Linux kernel is using drivers to make it possible to work with anything. If you want to work with LVM, you need some drivers as well. But you know, there are so many annoying little systems that want stuff from the Linux kernel. And the Linux kernel doesn't want to consider all these different annoying systems. And that is why the Linux kernel works with generic interfaces. And the generic interface here is the device mapper. So device mapper is a generic system that the Linux kernel knows about and that normal people, like our HCSA candidates, don't work with too much in real life. So the architecture is that LVM, but also Lux encrypted devices, but also MD, which is software rate, but also multipath and a bunch of other storage solutions are all communicating to device mapper. Now at the device mapper level, you get devices with names like dev DM-0 and dev DM-1, etc. These are names that are continuously changing. You don't like that too much, and that is why LVM has its own devices. And these devices are known in two ways. Dev mapper is following the generic device mapper interface. So dev mapper VG-LV or /dev/VG/LV. The best way to refer to these devices is really the dev mapper device, because if you look in this dev mapper directory, you will always see all of your device mapper devices, and that is always going to help you to find out which device mapper device really you are dealing with. And we shouldn't spend more time on this right now, even if this is incredibly interesting and exciting information, but it's not our HCSA. So MB is asking, for the exam, will we need to destroy an LVM volume of, MB, I only read the first 3 words of your question, or the first 5 words. For the exam, will we need? Can you guess what my answer is going to be? In case you don't, my answer is going to be, can you please read the exam objectives? Because I can't tell you what you need to do on the exam or not. The exam objectives is what you should use for any questions like this. And B, I hope you understand, but I need to make sure that I'm not disclosing any sensitive information about the exam here. All right, now where are we? We are at the point that I've mounted my LVM logical volume, so we're cool. I'm going to tell you about slides. Yeah. Excuse me, I'm going to repeat a couple of things based on the slides. Tomorrow, we are going to resize a logical volume. And I'm going to split this in 2 days because I know many people think LVM is complex. And because of that, I like giving you generic overview when we are resizing tomorrow. Hopefully that helps. What did we learn so far? Well, we learned about LVM. LVM is one of the RHEL advanced storage solutions. And anything that goes beyond the traditional partition, that's what I call an advanced storage solution. Now, LVM is logical volume manager. It's used during default installation of Red Hat Enterprise Linux. And it adds flexibility to storage like resize and snapshots and more. Again, tomorrow you will learn how to resize LVM logical volumes. There is also these new technologies which are no longer a part of the exam. These are Stratis, which is a next generation volume management file system that uses thin provisioning by default. Stratis looks a little bit like LVM, but it's different as well. But hey, No more words about it because you don't need to know about it for the exam, and that's the only thing that matters. Likewise, for the Virtual Data Optimizer or VDO, which is all about storing files in the most efficient way. In the RHCSA 8 objectives, it was described as you need to know how to work with volume compression. That's what VDO is about. But that objective is no longer in the RHEL 9 objectives. So know that it exists, and that is all. We have seen that LVM works with three entities. The physical volume, which is a storage device, which represents the storage device. It's a 16-byte signature that you can write to any block device. And yes, that's true. Any block device can be used in an LVM environment. The volume group is the basic unit that represents all available storage. Cool thing about volume group is that you create your logical volumes from the volume group. And in the volume group, you can put a lot of physical volumes. I don't know how many exactly. I never met the limit. I do know that you can create an exabyte volume group if you want to. And you probably won't find an exabyte disk. And if you put as many disks in your volume group to make it exabyte, well, the result is that you can create an exabyte logical volume. Isn't that cool? Logical volumes are based on the volume group. They don't look at the individual disks anymore. We have seen the procedure. So you need to create a partition and set the partition type to LVM. Be prepared for that on the exam. Yes, it's possible to use a complete disk in LVM. But the nicer solution is to use a partition as a physical volume. Because the partition is an additional layer, and you can use a partition type to make it easier for the operating system to find what is going on. So PV create is what you do. Then you use your VG create, followed by the name of the volume group that you want to use. That's the name that you assign for yourself. And then you use something like LV create minus N LV data minus L1G. If you don't use minus N LV data, you get an ugly device name like log vol 00 and log vol 01. These are meaningless, so you don't want to use them. Next, you use MKFS to create the file system. You put it in etcfs step, and then you are good. We have talked about extents. And extents are the elementary blocks of LVM allocation. And the extent size is what you define when defining the volume group. This, my dear friends, if you don't know what an extent is, this is where you will have a hard time on the exam. So please remember, physical extent is a property of the volume group and not of the logical volume, neither of the physical volume. And use VG create minus S followed by the size that you want to use if you want to build logical volumes with a minimal extent size. And obviously, the extent size dictates what the minimal allocation unit is in your logical volume. So every volume created from a volume group will have the same physical extent size. And VG display can be used if ever you want to find out what is going on. And with that, I'm done for today. Tomorrow, we will start talking about resizing logical volumes. Folks, don't leave yet. I have a couple of minutes for questions and answers, but I also want to send you a pastebin. The pastebin contains all commands that I've used today and yesterday. And I will also include my complete ETC FS step, because we have been in FS step so many times. Pastebin is a link, and I will send it to you in a minute or so. I need to generate it, and that takes a minute or so. If you cannot access the link from your work computer, bring it home. Pastebin is providing lots of advertisements. That's why corporate firewalls sometimes block it. Bring it home because it contains all commands that we have used, and you may like that. So I'm almost done with the pastebin, and let me send it over. If you still have any questions, folks, then you better hurry, because if not, I'm going to call it a day. Yay, I can see questions that are coming in. Oh yeah, I had a question that I overlooked. BD is asking, when is the next live RHCE session? The RHCE session is going to be in January. And BD about EX374, that's Advanced Ansible. BD EX374 is long term. Right now, the closest thing I got is the recorded video course Ansible from Basics to Guru. I want to update that video course March 2024 and make it EX374 compatible. I hope that helps. JS is asking, JS, I love it. I love off topic. And hey, off topic is allowed at the end of the day. JS, you have probably missed it, but let me show you the drawing again. And JS is asking about my Greenland trip. I came back 1 week ago from the Greenland trip, and the reason that you are looking at my drawing is not because of the drawing, but because of this. This is me on the Greenland ice cap. Fortunately, it was warm. It was only minus 15 centigrades when I was there. I ran a half marathon, which is incredible. It's an incredible situation. Please enjoy this beautiful Greenland ice cap. It's the most amazing thing that I've ever seen. TL is asking, I'm having a hard time accessing Grub bootloader using graphical interface. Can you please access on how I can do that? TL, can you give me more detail for this question, preferably tomorrow? When you say accessing Grub using graphical interface, Grub is the bootloader, and Grub comes at the moment that you don't have a graphical interface yet. And that's the part that I don't really get about it. And oh no, you don't see the ice cap. Let me share my screen again, folks. So there we go. This is what I wanted to show you. Now it should be all right. So TL, be more specific, because the Grub boot menu comes all the way in the beginning. Maybe you mean that you have a hard time seeing the Grub boot menu. Well, then after you reboot, press the escape key. After the firmware hits in, press the escape key and you will see the Grub boot menu, and that is hopefully going to help. Right, MA is asking, what would be good to study today? Well, if you look at the recorded video course, the lessons about storage, so the lessons about partitions and LVM, that's what I would recommend. And if you have a moment, check out the recording